Good morning and welcome to .NET Virtual Conference presented by CSharpCorner. My name is Mahesh Chand. I'm a co-host for this conference with May.
Hi everyone, I'm May McCreary. I'll be hosting with Mahesh. I'm very excited to be here. We have a wonderful lineup of speakers and I'm very excited to spend a whole day of learning with you. Back to you, Mahesh.
Thank you. And looks like we have people joining us from different parts of the world. I see people joining us from our North America, from Europe, and from even Asia. India is a big number right here. Welcome, everybody. Welcome to the .NET Virtual Conference presented by CSharpCorner. If you are joining us first time, CSharpCorner is a community of 3 million members, mostly around Microsoft technologies. And we do CSharpCorner does these conferences almost every month on different topics. And today we are here at .NET Virtual Conference. This is a 2-day event, today and tomorrow. It starts at 10 a.m. Eastern. So if you are joining us today, definitely check us out again tomorrow. Both days we have very exciting sessions. We have great keynote speakers. So let's talk about keynote speakers. Today we have two of the biggest name in .NET world, Scott Hunter from Microsoft. He's the program director at Microsoft. So I'm sure a lot of you guys who are working with .NET already know Scott. He's the person in charge of .NET. So anything happens with .NET, it's .NET 5 just came out. He is in charge. He's the person managing the whole team. And then we have other great keynote speaker, Kendra Havens. Kendra is a program manager at Microsoft. She's very heavily involved in building, .NET and Visual Studio tools at Microsoft and more. So let's hit it. Let's invite our keynote speakers. Simon. Hey, Scott, Kendra, welcome to the show.
Hi.
Welcome. We're so excited to have you guys. Where are you both joining us from?
So I'm joining from Redmond, Washington, right by Microsoft campus. I live about 5 minutes off the campus.
And I'm joining from Los Angeles, California, just temporarily getting some sun while I have to work from home anyway.
Wonderful.
Anyways.
How are you guys?
We're
Good.
great. It's for .NET, we're just like 3 weeks away from releasing .NET 5, so it's it's getting down to the wire.
Wonderful.
Exciting time. All right, guys, welcome. Our stage is all yours. Go ahead.
Okay.
It's all you. We'll be watching.
Okay.
Okay, my screen should be shared.
I can see it.
Awesome. Need somebody to verify. And so we've already been introduced, and so we only have a limited amount of time, so I'll just skip through this really quickly and hide that. I like to, for folks that don't know, I've been at Microsoft since 2007, and I worked on .NET Framework, and I worked on .NET Core, and now .NET 5. And I always like to say that when we first started .NET, we only did desktop and web. That was back when I was first in the team in 2007. But over the years, 2010, we added cloud. A couple of years ago, we bought Xamarin and added mobile. A lot of folks don't realize that a lot of the games that you play on your Android or iOS device that are built with Unity are actually running C# in the background. IoT is a space that we've added in recent years as we've supported things like ARM32 and ARM64. And we have an awesome library for machine learning called ML.NET. So, we keep expanding the things you can build with .NET. Folks always ask how we're doing. We shipped .NET Core back in technically like March of 2017. That's when the Visual Studio release that supported it came out, and since then we've added 1.5 million .NET Core developers. On the Stack Overflow survey for most loved frameworks, .NET Core has been #1 both in 2019 and 2020, and ASP.NET was also one of the most loved frameworks as well in the 2020 survey. .NET kind of came to the open source world late. A lot of the competition that we have, things like Java, had open sourced years and years before we did. We open sourced in 2014, but it's pretty cool that today we are one of the fastest velocity projects in GitHub. We've taken over 100,000 PRs from the community on .NET since then. C#, our primary language in .NET, is a top 5 language on GitHub. And then the thing that that we really care about a lot in .NET is performance. As we started doing the modernization of .NET with .NET Core, we had to go figure out what's one of the big things that we really, really care about and why somebody would use .NET. And we decided to focus on performance. And so the Tech and Power benchmark, you can see that we're always in the top 5 or 10 on the plain text benchmark. And .NET 5 is going to improve us greatly in the JSON benchmark and the Fortunes benchmark, which the Fortunes benchmark does data, talking to a database, using APIs. And so having .NET be one of the most performant platforms is a big goal of ours. .NET all up, how are we doing? I'm super excited to say that we have 5 million active developers in the Visual Studio family every month using the product. Just in the last year alone, we've added a million new developers all up. 600,000 of those were .NET Core. And then the number of people that are actually running our publishing tools to publish to Linux is over 2 million last year. And that just shows you the importance of us adding the cross-platform capabilities that we added in .NET Core to the platform a couple of years ago. We currently have .NET 5 release candidate 2 out today. And .NET 5 brings a bunch of new capabilities. Single file applications, which I might show quickly, is one of those things where you can basically take a .NET application, compile it down to a single exe. We've had that feature before in the .NET Core 3 wave as well, but it's much faster in .NET 5. .NET Core 3 cheated a little bit. It actually unzipped the exe and then ran the folder that it unzipped. Now we actually just run the exe by itself. We've reduced the size of container images. Once again, if you're building microservices and doing container-based development, our base images are all down by about 20 to 30% year over year. There's a bunch of web and cloud investments, and I have a slide that I'll talk about that in a little bit. And folks might not know, we already have ARM support for Linux and stuff, but now that Microsoft is shipping Surface X's that actually run on ARM microprocessors as well, we're adding ARM64 support to Windows ARM64 support as well. One of the big pieces of feedback we got in .NET Core 3.1 was where did click once go? And because of that, I'm happy to announce that we brought click once back. And I won't demo it today, but I'll be demoing it soon. Continued performance improvements and a bunch of new language features. I'm not going to go deep into language features because I know Mads is going to be here tomorrow, and he will talk about some of that. Here's a brief look at some of the .NET 5 performance improvements we've already done. You can see here that if you're running on Linux, the performance of sockets is up by 30%. JSON serialization all up across all the platforms up 20% since 3.1. Serialization of large collections and arrays is 3 times faster. And once again, the biggest way that we actually make perf better is by not allocating memory. And so you can see they're now don't allocate memory. And my most exciting ones of these benchmarks is the gRPC stuff. So gRPC, if you don't know what it is, it's something we shipped in .NET Core 3.1, and it's contract-based APIs. Very similar to WCF, but it uses a different wire protocol. The cool thing about gRPC is it's cross-platform, meaning that you can build your gRPC service in .NET 5, and you can call it from Java, you can call it from JavaScript, you can call it from Python, Go, whatever. But we are one of the fastest implementations of gRPC that there is. You can see in this chart here that we're faster than Java, we're faster than C++, we're faster than Go. And even though we're just a hair slower than Rust, this benchmark was taken before we got this close to RTMing .NET 5, and we've made more perfect improvements since then. So we think we'll actually beat Rust in the final RTM. What's our release schedule look like? So .NET 5 is going to ship on November 10th. So just a few weeks away from now. And when you look at this, you might go, well, why is it every November? You know, .NET Core 1, 2, and 3 had random release dates all throughout the years. You didn't know which ones were supported, which ones were not. And so we're just trying to simplify things down to make it very simple. So you can see that we'll ship .NET 5 this November. We'll ship .NET 6 next November, so on and so on. Now, every other release is a long-term release. And what long-term release means is you get 3 years of support. But I've learned from talking to customers that people are confused by this a little bit. Even if you're on an LTS release, you should be updating your application every month, because every month we have a patch for .NET. And so I had customers tell me, well, I'm going to wait for the LTS. Well, if you're updating every month, you don't really need to wait anyways. You should just be updating your .NET every month anyways. And one of our goals in .NET 6 will be to make that transition from .NET 5 to .NET 6 under 10 minutes per application. So we're going to have a very high compatibility bar. So it should be very easy for you to stay on the latest version of our releases. And then, of course, I just mentioned earlier that November 10th is the launch date for .NET 5. And so we will have our own virtual conference. It's kind of like this for 3 days. It's about half community and half Microsoft. It'll start on November 10th, and there'll be an updated Visual Studio and all the tech on that day to take advantage of .NET 5. Now, while we're talking about .NET 5, I want to talk about our vision with .NET moving forward. So you might ask yourself the question, well, why did you drop core? Why did you skip version 4? We know that .NET Core / .NET 5 is the future for .NET. You know, if you're using the older framework, that's fine. We're going to support that forever because it's part of Windows. But all the new innovations happening in the .NET Core space today. And we want to make it very clear that moving forward, that's where all the innovation is. And so what you'll see here is our plan with .NET 5 and 6 is to slowly take the .NET brands, merge them together into a single brand, which we'll call .NET. And then over the 5 to 6 wave, we plan to do what I'll just describe. So which is, we want to have a single SDK. If you download .NET, the .NET SDK, you can build all those app types I showed on the earlier slide: web, mobile, desktop. We want to have one BCL. You know, you might not know, but today we actually have a variety of BCLs. We have one that's run, if you're running a Xamarin app, you're using the mono BCL. If you're building a 3.1 Blazor app that's using WebAssembly, you're actually using the mono BCL. With .NET 5, we switched Blazor to the core BCL. And with .NET 6, we'll move all the Xamarin tech to the core BCL. And if you don't know what a BCL is, that's the base class libraries. That's strings and all the regular .NET types and stuff that you use. And we want to have a single unified tool chain using the new project system that we have in the .NET Core projects. We want to have awesome cross-platform native UI. That means we'll be merging Xamarin into the stack. We want to have awesome cross-platform web UI. That's the Blazor tech that we have. And we want to have awesome investments in cloud-native technologies. You know, containers, Kubernetes, Docker. How do you do those things? And then, of course, continue to improve. And I believe at the end of .NET 6, we'll be back to where we were with .NET Framework 1.0, which is we'll be best of breed for all the app types that there are. I'll skip this really quick. Mads is going to be here tomorrow and talk about C# 9. I might show a quick demo of top-level programs in a second here. Cloud native investments, a big area in .NET 5. REST APIs is something that we really care about. And so what we have here is we've added in web API projects in .NET 5 support for Open API. And what Open API is, it's a metadata that describes your API. You don't have to do anything. Just build your APIs in .NET 5, and we'll create this for you. Now, there's a benefit for this, is when I have that Open API, I can do tooling around my APIs. And so what this means for us is, if you control F5, a web API project, now you'll get a dashboard where you can actually test your APIs live. From that same Open API, we can do client generation. This is like the WCF features we've had in the past, where you have an API, you right click and say, add the API to my project, and we generate the C# code to call that. And we even have publishing to things like Azure API management built in the tools. gRPC, that's our binary kind of protocol version of doing APIs that are contract based. REST, you can have an API that has, sometimes has all the parameters, sometimes doesn't get all the parameters, and the tech can just handle that. With gRPC, it's contract based. You basically have a contract saying, here's the parameters and here's the return types. You can get a little bit more performance out of it. That's why you might want to choose that. And once again, it works the same way. You define your server, and once you have a server defined, you can actually right click and say, add a client, and we'll generate all the client code to call the server for you automatically. We have, I mentioned earlier about 2 million publishes to Linux. Well, publishing to Linux is one thing. What if I need to develop and actually make sure my app runs correctly on Linux? Well, we have awesome cross-platform development with WSL, which is Windows Subsystem for Linux, built in the .NET 5 RTM timeframe. Smaller microservices. I'll show very quickly how you can build a microservice that used to be about 50 megs, and now it's under 20 megs in .NET 5. We're also building a high performance reverse proxy. This is kind of an internal benchmark for us. The technology behind a proxy, that's something that sits in front of like Azure, is meant to be a test for us to make .NET as fast as possible. And then we're working on making it super easy to build microservices. And I don't have time to demo that, but I'll talk about it. So our way of building microservices is what we call Project Tye. And so this is an example of an application. This is a microservice style application. You've got your front end web app, and then you've got a variety of services. Well, that's great. How does the front end application know how to find those three services? Today, you would actually hard code IP addresses and ports. Well, Project Tye will take that away from you. You actually can just call them by their names, and we'll do all the mapping for you. And that's really important because on your local machines, they'll be on different IP addresses and ports than they'll be in the actual cloud. Next thing is dependencies. What if that service, and one of those services depends on something like Redis or SQL Server? Well, historically, what you would do is you would just go and install all that stuff locally on your machine so you could develop. Yuck. I don't want to do that because then I might have to pave my machine in the future because I don't want that stuff on the machine. Well, with Project Tye, all you do is reference. You put a reference in the Tye configuration file to the container that contains those things, and we'll download it, boot it up, and run it for you automatically. So no longer do you have to install SQL Server or Redis or anything else if you want, without writing Docker files. And then the cool thing is you can run these apps locally. For performance, you can run them just without containers. You throw a switch on it, we'll run it in containers, and you can even run on Kubernetes. And once again, you've not written Docker files or Helm charts or any of the crazy technology there. You just develop like you always do. And then this is probably my favorite feature. We've never been great at this. If you run more than one project in .NET, well, how do you know what the logs are for each of the projects? How do you know what the performance counters are for each of the projects? How do you even know what ports and IPs are running on? And so now when you actually launch one of these apps, you can get a dashboard that shows you all of the apps that are running, and you can click into all of them and see how they're doing. And then finally, the coolest part of this is I demoed this just to some of my bosses just a few weeks ago, how I took one of these applications that was made up of 3 components, and in about 30 seconds, I was able to take it and publish it to a running Kubernetes cluster in the cloud. And that's Project Tye. I've got a few minutes to do like about 9 minutes worth of demos before I hand over to Kendra. So let me stop here and do a couple things. So the first one I thought I would do is this is a cool demo that's using an extension that I said will be publicly available around our launch time. It's already available today, but it's kind of a beta. And so I could do something like this. This is just a regular Razor page web application in .NET. And you can see what I've done here is I basically made it print out the operating system version on the screen. So not super exciting. There we go. And so let's just run this, and it'll do kind of what you expect. It's going to print out that I'm running on Windows, because I am. Okay. And once this comes up, I'll show the cool kind of thing that we've done here. So here it comes up. Wait for ISExpress to come up. It's running on Windows NT. You can see I'm running Windows 10. You've seen this before. Kind of simple. But what's cool here is I can now drop down here and I can select WSL2. And that's the Windows subsystem for Linux. And you can see as I do that, it's kind of verifying that all the stuff in Windows subsystem for Linux is set up correctly for me. And now, put a breakpoint here if I want, and I can control F5 again. And now things are going to be a little different, meaning that instead of running my app on Windows, you can see Kestrel boot up, and now you see that I'm actually running on Linux. And so the developer experience is just as fast on Linux as it is on Windows. It's super, super fast. I can also do this. The debugger works through here as well, so the debugger actually will jump into Linux. And you see my breakpoint hit, and hit that, it shows Linux. And this is just showing how we're going to make developing on Linux just as easy as running on Windows, all on Windows. I want to show something else that's kind of cool as well. This is a microservice that we wrote in .NET Core 3.1. And this is about the minimal size microservice you can write today. So there's all in one single file. You can see public class program, void start main, and then I create a host builder and I write a little bit of code to basically spit out to the screen, hello world. Well, what does the same app look like in .NET 5? So let's go back. This is 23 lines of code, 22 lines of code. I can kill that blank line at the bottom. The same app in .NET 5 is 16 lines of code. And that's because if you notice here, there is no program. There's no class program. I'm using a new feature in C# called top level programs that lets me just say, I just want to go write some code. I don't need to have all that boilerplate. There's no main. It knows in this particular case that just to start writing my code right from scratch. And so we're trying to make it where you can, if you look at some of the other technologies for building microservices, they all end up with like these 5 or 6 line microservices. And we wanted to make sure that in .NET you could do the exact same thing. Now, there's something else that's kind of cool here as well. And that is I can come over here, and if I take my first project and I right click on it, and I go to publish, I've already done this once before, but I want to show some new features here that you might not be aware of. You can publish a web app to a folder. That's all I'm doing here. If I click edit and I go to settings, there's a bunch of options I have here. And one of these options is produce a single file. And then another option is to trim out the unused assemblies. And this is a preview feature. This is something we've improved a whole bunch in .NET 5. So I've already done this. I don't want to do this on stage here, but I can grab the path here, bring up my file explorer, and you're going to see here that this microservice, this 3.1 microservice, is about 45 megs, which is still not bad. That means that app just by itself is everything you need. You don't have to have any .NET on the machine. You copy that to a server, and you're ready to go. Now let's go take look at the 5.0 application, and we'll do the exact same thing. I'll go to the publish. I've already set it up once again to have the trimming turned on. Grab the folder here. now the application is about 21 megs. So you can see we've shaved almost 30 megs out of an application. So this is the smallest microservice you can build. You can take that 21 meg executable, copy to the server, and you're ready to go. And this is one of the areas where, if you ask us about what ahead of time compile is, this is where we're trying to go to get better and faster at these types of things. Okay. So I want to show one final thing. Let me close out these Visual Studios, don't save. I mentioned before OpenAPI. And so what I'm going to do here is I'm going to create a new project. And I've got a preview feature turned on where the templates show up a little different. It's a little slow right now on my machine. And what I'll do is let's create a web API. Core web API. And it doesn't matter what we call it. And notice by default, we always stick to the long-term support version of .NET, but I can drop that down, select .NET 5. And when I did, this new checkbox opened up, enable Open API support. This is this feature that I said before, lets you actually test APIs locally and makes it very easy to build clients for them. So I'm going to leave that check, that's on by default. Click create here. And what that does is we actually take an open source package called Swashbuckle, and we install it in your project by default, and we wire it up. So you don't have to discover that or figure that out. That's just done by us. If I drill down here into packages, you can see the Swashbuckle right here. We've added new to your project to make this work. And so this is just a test API. But now if I come up here, and we'll just start with that debugging. What should happen is normally an API project would actually just kind of error out because there's nothing there. But now you're going to see here's my application. It's a weather forecast application. I can press get. I can press try it out. That then returns the data automatically for me from the request. That. There you go. You can see the response body for that. And so now just built in, you can easily build and test your APIs. If I wanted to, I could have started with the debugger and could have stopped, and things would have worked just the same way. And so this is just the continued work for us to make API building easier in .NET. I'm not going to do it, but if I wanted to, I could have right-clicked. You would never do this in the same application, but I can go to connected service. And this is where I can add a reference to an Open API or a gRPC project if I wanted to write that client automatically. Now, with that said, I think I've used my time up, and I'm going to switch over and let Kendra show you some cool productivity tools.
Hey, thanks, Scott. So let me just share my screen. Okay, that should be up in a second. Should be some code. Awesome. Okay, I think we're rolling. So just to build on to what Scott was talking about tooling and .NET 5 being part of our major plans and lots of excitement around that. I have a lot of new tooling stuff to show. So let me give a quick summary of what I want to talk about, and then we'll hop into some more code. So Scott just mentioned performance on .NET 5. I have some multi-targeted tests that we can kind of analyze, look at some more of the kind of even smaller performance gains, I guess, that really add up. We can talk about new .NET 5 analyzers as well as analysis levels. Then I'll show you a ton of code fixes and refactorings and how to sort of manage all of those with code cleanup and editor config. And if you want to follow along, this demo is actually open source. You can go to aka.ms/blazormemorygame, and we have comments throughout the code on where you can actually trigger a bunch of code fixes and refactorings. So easy to discover, easy code snippets to see. So first off, I am going to dive into the performance a little bit more. Stephen Tobe on our team gave this excellent blog post on all of the little improvements that we've made in .NET 5 since 3.1. And some of these are really cool. He ran benchmarks down to microseconds and nanoseconds on some of even the most basic operations like to upper or to lower or regex searching or JSON serialization. It's super cool. If you want to see sort of proper benchmarks running, I'd really suggest checking out this code, or the blog post. But I have some code to kind of demonstrate what's happening. And my computer was running a little bit slow. I'm not sure if it's live stream bandwidth craziness, but let me go ahead and show you. So I have a few tests, and I guess we'll walk through those just a little bit. So this is just a summation running over an immutable list, 1,000 items long. So we're going to see this execute. And next, we have a regex search that's going out to the Project Gutenberg project, really cool, open source kind of books collection, huge library. And it's doing a regex search over the entire work for the words love, Romeo, Juliet, and it's doing that a bunch of times. So it's going over Romeo and Juliet, that book. You see some really cool regex highlighting there. And the last one is a JSON serialization test. So yeah, just running over a datetime array and serializing what's there. So if I go ahead and open my test explorer, you can see that my tests that I have are actually already divided up between target framework. So let me show you my CS proj really quickly. So these are just 3 tests, right? But they're multi-targeted. So I'm targeting both .NET 5 and 3.1, and that appears in the test explorer. So I'm doing that currently by having this target framework box checked. You can totally organize your test explorer by sort of whatever group bys that you want, and you can have multiple levels of group by. It's totally flexible. So let's do target framework. The order in which you click your group by options is the hierarchy in which they will appear. So we'll expand those, and you can already see that Net 5.0 is a total of 1.2 seconds. Net 3.1, and again, these are the same exact tests, 1.8 seconds. So just little things, some of our basic functions are running much faster. I mentioned like 2 upper and 2 lower strings on, or calls on, characters and strings. That's crazy. So JSON serialization, it's 286 milliseconds. Compare that with 542, almost like cut that time in half. These aren't good benchmarks because testing the duration is a little bit, we include more than is necessary. We include like more test operations and everything than just the test run time. And with threading and everything, the times aren't always like super accurate. So if you ran proper benchmarks, they'll actually show an even greater improvement. But it's pretty cool. So compare 945 milliseconds to 1.2 seconds. Not bad. I wanted to run these. I'm not sure if my computer is actually acting up a little slow. But let's give it a whirl. Why not? We're doing it live. Should have probably. Let's see. Yeah? That's what we want to see. I don't know, started running a bit slow. I was frantically restarting Visual Studio as Scott was presenting, so, oh, there we go. Well, build succeeded. Okay, now we gotta do the test runs. I actually have a screenshot of what this should show, just in case I needed to. So it's really exciting to see these performance improvements in just the most basic levels because you know those add up as you go. You know, Visual Studio just decided to run slow this morning. It's still waking up. It's an early day over on the Pacific Coast time zone, so. Oh, now we're starting. Well, I'm pretty sure these all up times will be inaccurate, but at least you saw the first kind of millisecond measurements that you saw before. And you can already see .NET 5 is done faster than 3.1, so I'll probably go ahead and cancel that. All right, but I'll push these tests later and you can run them for yourself. So that's performance. Very, very cool. Obviously, Steven's examples are going to be much more performant than what I showed. So definitely check out that blog post. Now, something new, we also added in .NET 5 are new .NET 5 analyzers. And we're actually kind of added these analyzers in a completely different way. So we've learned a few common coding mistakes over the years, but in order to add warnings for them, we actually couldn't. We were holding back. We were holding out. This is because adding warnings for all of the users that have warnings set as errors, that will cause source breaking changes. So we couldn't immediately check in a bunch of new analyzers in our frameworks, even though we think these are really common coding mistakes in existing code. And we always hear from our awesome community that they want more code quality. They want to catch things earlier. They want to catch stuff before runtime, before they go into production. And if there's any kind of coding guidance we can give, we should. So we've tried kind of packaging these elsewhere. You had to kind of install like security analyzer, NuGet package and all of that. It didn't actually ship alongside the APIs. Now in .NET 5, they do. So these are specifically .NET 5 analyzers associated with the .NET 5 SDK. So you're getting actual feedback from the APIs themselves on how to use them. So let me show you a little bit of how that works. So first off, this one's entirely new. So this is warning when the expression is always true. This is comparing a date time, or asking if a date time is null. And it can't be null, actually, because a date time is a struct. So we know this is always going to be false. Now we're giving a warning for it. So to fix this, you could delete this code, or you could actually mark the date time as nullable if that's a really intentional thing you're going to pass to this method. So then we won't give any warnings, and it'll get rid of the error, or the warning rather. So next, this one's really important. I actually almost want to turn off the analyzers and see if people immediately, these issues jump out to them. So this is actually calling a stack alloc inside of a for loop, which we do not recommend. It can cause one of the most common sort of classic Stack Overflow exceptions. So our recommendation is to move this outside of the for loop. So you're allocating what you were intending, but probably not, in a whole loop. So this one's pretty cool because this is also helping you better use range operators and span. So, whoops. I'll go ahead and open that. So this knows that you want a read-only character from a string, and you're using range-based indexers to access that, and that is actually creating an extra data copy. What you want to be using is the .asspan call, and we actually have a code fix along with this one, so it'll insert asspan into your string, and then you can access it in a more efficient way. And I saved the best for last. This one kind of blew my mind that we didn't already have a warning for it and such, but as I said, we were very hesitant to add a bunch of extra warnings because we don't always know how that will impact the millions of people that we send them out to. But it's so good when we do get these in the default experience. So maybe we already see what's wrong here. The comments are giving you a hint. When you catch an exception, you don't necessarily have to throw the exact parameter that you caught. And actually, if you do, it will change your stack information. So what you should be doing here is just throwing with no variable. Just throw. Don't rethrow. Pretty powerful stuff. We know that these might be very commonly used. Oh, let's see. See, I'm having a bit of technical difficulties this morning. I swear, Scott Hunter, I swear that I did this 1,000 times yesterday. Of course, whenever you do a keynote with your boss, that's when Visual Studio will have the most issues. Let's see. I think I'll just do a restart. What would hurt? You guys will see my cool background. Let's see. So something that is cool that we've added with these new analyzers is basically the ability to decide when you get them. So as I said, we were worried about adding these in, and now they're in .NET 5. But you don't actually have to address all of these analyzers at once because, again, we haven't had them before. Obviously, you were able to run code and ship your project. You could live without it, right? So we've actually introduced sort of a new concept on how to access analyzers. And those include, I'll just go over to my slides really quick, analysis levels. So any project that targets .NET 5 will automatically have the highest analysis level. It'll be 5, trying to stay in sync with our numbers. And with projects that target even earlier frameworks like .NET Core App 3.1, you can actually still get .NET 5 analyzers with analysis levels. So just as the screenshot shows, set the analysis level to 5, and you can get sort of the latest analyzer advice from your editor without actually retargeting your project. So that we're super cool. We're really excited about. And you can always go down to 4, even if you are targeting .NET 5, if you're really just trying to kind of retarget, migrate to the fastest framework that you can use. And you're not ready to go and do sort of that extra set of refactorings and take care of those warnings and that feedback. So you can delay feedback to when you really need it. And, oh good, now I'm not getting any warning. Let's see. Well, what I was going to show is we do have a tooltip that we can actually edit the editor config. And that looks something. Playlists are excited to be alive, like this. So right now, that was the rethrow warning. And the severity is at a warning level. So if you think this is really important and you want to catch all of the places that you do this in your code, you can always promote it to an error, and then it will appear as a red squiggle. And if this is something that you don't need to see as much, you can actually kind of deload it to a suggestion. Let's see if that loads. Oof. Oh. Same issue. Excellent. I'm sure this won't impact the rest of my demo at all. I had so much more to show. Okay, so I'll give the editor config description. Visual Studio is busy. Oh, good. At least there will be a bug report for for what I'm experiencing right now. Very good. Thank you, Action Center. Okay, so at least I can talk through editor config a little bit more. So editor config is super valuable. It lives at the root of your repository, and it actually documents all of your code style, so it's consistent across your team, and you can kind of customize your IDE, tell which analyzers are most important and which ones you want to silence, and it's all contained in one place along with your source code. So when your team pulls from your repository. They're getting the exact same code style suggestions and analyzers that you're getting. So that's really cool. So one of those is, and I'm not sure it'll come up, but we now have support for adding a file header to your project, and to all of your documents in your project. And it's super cool in that when you create a new file, it'll actually also automatically add it. So that's all built in. It'll travel along with your code and you won't lose that. It's not like a custom IDE setting that not everyone has. So it leads to like inconsistent file headers and stuff throughout your project. No. We got that. And you can apply this with code cleanup. So you can right click. You can right click and analyze and code cleanup from here. And you can configure code cleanup profiles. So I actually have made sure that if I go to code cleanup, it's also this little broom icon if you want to run it on all of your current documents. So you can actually configure it. I thought I could just sneak it in. I could just click and it would suddenly start my analysis working again. Well, I restarted and you kind of get the idea. Definitely be looking into this later. Ah, yes, the excellent, this bar. This is what I love to see at 7 a.m. So that was going to just insert the file headers for all of my open documents, and I can configure that in code cleanup. So that's how I know which fixers code cleanup will apply whenever I click it. So it can be my easy go-to solution. Cool. So I had a lot more refactorings and whatnot to show, but I don't think any of them are loading, which might be okay because we're almost about at time. So let's see. Should we do a last-ditch effort? What do you think, Scott?
Go for it.
Let's see what is loading. Hey, okay, so we can show parts of the demo. So I do have XML comments. So new XML comment styling, you can actually add hyperlinks into your XML comments, as well as italics, bullets, numbers, and lists, all that kind of thing. Pretty cool. And let's see if that, and we now also have a Heradoc. So anything that is implementing that what you have XML comments on, it'll actually start showing up in quick info. So all I have is in Heradoc up here, but this card is actually getting all of the comments that were on my animal card. And what an animal card is would make more sense if I had been able to get to the debugging steps and whatnot. But yeah, that's kind of all I have. You can check out the Visual Studio preview, which I promise works a bit better when you're not live streaming, having a dozen chat apps open and all of that. So you can check out the VS preview. And please download the code fixes and refactorings demo app so you can kind of try them out for yourself, get comfortable with using them, and yeah.
Awesome.
You're muted, Mahesh.
Oops. Yeah, I know it's a little early there, right? 7 a.m. is too early for, even for the Visual Studio, but I know StreamYard may have some issues. But thank you, Scott and Kendra, for so much. I think we learned a lot. .NET 5 looks like there's a single SDK coming for Windows, web, mobile, services. Everything will be just using one SDK. That's awesome. We learn about some of the cool performance tips and what the difference between .NET versus .NET 5 is. This amazing. It's great. And I know working with regex and strings and datetime and even JSON serialization, it just time is critical there. Looks like we learned a lot about .NET. .NET definitely has a great future because people always ask me, hey, what is future of .NET? Well, it looks like now .NET is in great hands. and I can clearly say it's definitely has a great future.
Yes, thank you once again to both of our keynote speakers, Kendra and Scott, and thank you for being part of our community here at CSharpCorner.
Yeah, have a great conference. I'm super excited for the next day and a half.
Thank you.
Absolutely. Thank you for having us.
All right, it's time to welcome our next speaker, Raffaele, all the way from Genova, Italy. Raffaele Rialdi.
Good morning, Raffaele. How are you?
Oh, how good is it to be here with you, my friends. It's a great pleasure to be part of this conference. Thank you, Kendra. Thank you, Scott. And fantastic.
What time is there and where are you speaking from?
Oh, it's 5 p.m.
Oh, wow.
So
All right.
not too bad. I mean, there
Not
are
too
other
bad.
parts of the world that are living in the night or too early in the morning. I am a night guy, so it's perfect time for me.
Your day is starting.
Yeah, of course. So should I go?
Take it away, Raffaele. The stage is yours.
We want to go straight to the point, and so I will share my screen. Let's see here. Okay. Can you confirm that everything is good?
Yep, looks great.
Okay, let's go. So welcome to my session of Power Your .NET Core 3 application with the new generation of diagnostics. By the way, we will also talk a little bit about .NET 5 at the very end. But it's important that this stuff is already available so that you can leverage immediately this stuff with the .NET Core 3. And I will briefly introduce myself. I am Raffaele, also known as Raf, and I work as a consultant in different kind of companies. It is exciting to work with from one side on the manufacturing environment. This is one of the most recent things that I did in the latest 5-6 years, and then have been and also involved with Formula One in racing, in the healthcare environment, which is very different from all the others, and as often happens in the financial environment as well. So you can see me in many conferences as a speaker. I have been in United States, in Italy, in Romania, in Bulgaria, and Russia. I have been in Siberia, what an exciting part of the world to be in, but also in other cities as well. And I am a proud member of the Microsoft MVP family since 2003, so 16 years now. So it's nice to share with you my MVPsness and all the stuff that I learned all over those years. I want to first introduce my new co-authored book, co-authored with Marius and Kit, which is about C# programming and covers the version 8 of the language, which is very exciting times to see the evolution of the language. Yes, tomorrow Mads will talk about the version 9, but there are many things that are just an evolution of version 8. So that's a good occasion. And for you guys of CSharpCorner, there is this discount that is valid until November 1st. Let's go on and go straight to the program from today. Our goal for today is ambitious because I am a big fan of automation. And automation is something that goes side by side with everything involved in software. And I want to automate the diagnostic process, but in production. I mean, there are several times where we can understand, we can know in advance what is going on wrong in our application. So the two steps that we want to reach is, first of all, learn how can we trigger a diagnostic. What are the elements that can suggest us that something is going wrong in our application? And the second step is programmatically leverage the power of SOS, which is a library that is, I mean, is an add-on of WinDBG, but is also a library on CLRMD, which is pretty scary at the first sight. So it's very advanced. But now we have something that can give us the power of investigation without spending too much time in the too advanced stuff. And we will see a very, very large demo about this. At the development time, of course, you have all the power, but the power of the current debuggers is generalistic. I mean, they are not meant to diagnose specifically an application like the one you architect. So it is extremely important to know how they work. So Visual Studio Code, WinDBG, and the LLDB for the Linux environments. And of course, SOS is a powerful mate that can be used in order to diagnose at a very, very low level both the CLR runtime stuff, but even your application objects, and understand well how they work, how well they are working. So unless you are analyzing a dump, you don't want to use this stuff in production. That's the very first point, but that's pretty obvious. And the second point is that you maybe want to have a better diagnostics that is well suited for the specific application that you designed. You already know your application. You don't need generic debuggers. It's too tedious to understand what's happening in your application starting from a general purpose debugger. There are, of course, profilers that can be used in production, and there are many of them from Visual Studio, of course, but also third-party. There are .NET counters, for example, that is a great global tool in .NET Core. And there are also micro-benchmarking that, with the library benchmark.net, is a great investment in order to understand, to fully understand, as Kendra have shown during the keynote, how can you understand better where are the performance pitfalls? I can go very deep in diagnostic. I designed also a custom debugger for a customer, but this goes beyond the goal of this session. But if you are interested in this, please, you can ping me on Twitter or on the other social networks so that we can discuss separately. What about the troubleshooting in production? There are many problems there. I don't want to waste too much time in describing the things, but we have to focus a few points in order to understand better why we are going this way. Of course, you have logs. Everybody prepare logs because they are a good source of information. But sometimes it's not so easy to prepare logs on everything. You also always miss something that is crucial to understand how your application is performing. One other possibility is creating a dump. You can use the global tool .NET dump, which is perfect for this because it's not invasive, it's very small. You can move from one machine to another and capture that moment that you believe the application is not performing that bad, that good. And there are many other, Proc Dump, Process Explorer, Task Manager, Salt Dump, many others. But if you want to measure, for example, all the counters that can give you a bit more of information, because your sensations are good because you are designing the application, but you cannot know exactly what is going on from the internal perspective in your application. So .NET traces, .NET counters are very good tools for that. There is also .NET GC dump to monitor the memory in your application, and of course PerfView, which is a master tool that everybody involved in the debugging should know. In .NET 5, there is also .NET Monitor, which is pretty new and give you other kind of information related, for example, to HTTP and so on. But let's go further this and let's see what can we do. The challenges of dump analysis is that it's very tedious and repetitive and hard. Many times you can see, for example, I can dump all the memory that I have in my application, and if you find that there are let's say 10,000 objects, and you want to investigate to understand which one is which one brings you the problem, and you may want to see inside each object, and 10,000 is too much. I mean, you cannot repeat that command 10,000 times. It's totally crazy. So the investigation can be very tedious and also take a large amount of time. Another challenge is that you may have a hard time in understanding what is the precise moment in which you have to capture the dump in order to bring exactly the problem. So capturing is not that simple, and it's another problem. Another problem that we have in EU and many others, many other countries have, like Brazil and so on, are the privacy concern. So you are capturing something that is in production, that is maybe have sensible data from the users. There are privacy concerns, there are maybe secrets. And so managing with a human intervention a dump, it's risky. I mean, you have to have a delegation from the customer that you can watch and the content of the dump and so on. So this also very a big problem. It's of course everything that is related to humans is expensive, so you have to take care also for that. Our scenario for today is I prepared a pretty large solution that the number one is an ASP.NET Core application, which is a kind of classic. It's an MVC with some controllers, a few services that I will show you that simulate a huge work, even if there is nothing very important. And then, of course, you have the clients. Typically are the browsers, but maybe there are APIs exposed from this web application. And so you may have also automated requests and so on. What is going on? How can we understand what's going on in this application? So in order to simulate in a demo what is going on, I also created a console application that have a little menu. So it's organized in order to understand what's going on, how can we stress the application. And I will be very careful not to stress too much the CPU during the streaming, is that we can make GET request, so it's a simple GET, but the number you see here is the concurrent request. So this is 1,000 clients that are making at the very same time the GET, releasing a manual reset event, so that all the requests are made at the same time. The second is a simple post. Again, this is a 1,000 request, but this time we have a custom header. And this custom header is used for a specific purpose that we will see in a moment. The third request is an action on the controller that simulates some random exceptions. So we have like 1/4 of the possibility that there is an exception during this request. Then the slow post, so something that takes a long time before being executed. And two kind of leaks. The first one is with a blob, so it's a binary array, and the second is a large graph of custom objects. And of course, I had to prepare also the free leaks, so releasing the leaks, and GC collect in order to force the collection from the garbage collection, something that you should never do in production, of course, and not in your application, because make the GC go crazy, but it's useful for the demo, of course. And then lately, the CPU stress that increase like 4 processors at 100% of the CPU. Let's see for a moment these two applications. So we take Visual Studio, and the test web app is this one. We have the startup, which is the classic startup of any ASP.NET Core application. And you can see that we have several services. The first one is a singleton that is the custom header event source. What is that? We prepared a specific event source that we want to leverage. So you see the event source that is able to trigger a specific event counter that happens that we can, in order to signal that something has happened inside the application. When does this event source is used? This is used inside the middleware. And so every time an HTTP request comes to our application, and we are invoked here, of course, because it's a middleware, and we find that there is this header that is called the X-trigger header event source. Is contained among the headers of this request. I raise the trigger the header event count, and this allows us to like drive this trigger from the external. I can connect to the application from my home and send, I want to trigger something now, because I know that something is not responding well. The application is not performing that well. But you can trigger with any other kind of information that you may have inside your application. Then I have a CPU stress service. And the CPU stress service, very simply, is a CPU load that runs the primes calculation. So it's a very load. And then we have the memory pressure service. And this memory pressure just can make the allocation of some roots in static fields. You see the statics here. And they are either blobs or a long graph of object that contains random memory, and it's nothing special. And then we have also the simple state service, extremely simple, just increment a counter. And finally, they add controllers and the add Razor pages. All of this is very simple. I mean, the application doesn't have to make anything other special. We just receive a request and we respond with invoking those services. And this is done, of course, on the test controller. The test controller, and as you can see, is very standard. Thanks to the dependency injection, we receive those services, and we can do whatever we need. So from the simple post, I just log and result and return, so there is nothing. And the exception, I randomly throw an exception. On the slow post, I just thread sleep. I want to thread sleep in this case, not a task delay, in order to see some result on the CPU. I invoke the service to allocate an array and allocate something statically so that I can see a leak. The same with the graph post. And here I free or I collect the memory so that I can see the results. Well, all of this is very nice. Let's see the next step then. The next step is that I want to diagnose automatically. And so the basic idea, and this is not available in the demo just because it doesn't make sense for a demo. Ideally, you want to go in production with a kind of made application that is a kind of surveillance program that you want to make side by side to your process. So you go in production with two processes, not just one. The second one just listen to a special the diagnostic server that is new in .NET Core 3. This diagnostic server is listening to IPC requests. It's a special protocol documented on GitHub that is called that talks using named pipes, and it can be used using the Diagnostic client, which is a library available through Microsoft as a NuGet package, and is very easy to use. So basically, what does this made application do? It subscribes to the trace events so that we can listen to the event pipe and the event counters that are relevant for us in our application. If you want, we can listen to the application using event counters from HTTP, from the memory, from the CPU, and so on. Let's see this in action for a moment. So I prepared here, let's see, here .NET run, and I have the web application that is now running. Okay, our application is 13 and 652, and now I can run my .NET counters with the same number, okay, with the PID that I printed here. You can find easily the PID using the task manager or using even .NET counters alone, saying I want to monitor this process and I want to use those providers. So Microsoft ASP.NET Core hosting, and so that I can listen to the HTTP requests. I want to listen to the system runtime trace events. And I also want my custom RAF custom header, which is a special event counter that we provided. Remember that all of this stuff is available not only on Windows, but even on Linux, because even if they resemble the old ETW, which is still available on Windows, of course, they have been brought across all the platforms so that you can use this stuff in with whatever operating system you are working with. So the second, we can run this nice tool that comes from Microsoft, is a global tool, and you see that it's monitoring live this situation. Then I run my stress application, and the stress application is simply an HTTP client that is invoking all the APIs that I described before. But as you can see here, I have the concurrent request that changes depending on the type. So if you watch carefully to the ASP.NET Core hosting and see the total request here, this 0 is going to change because I invoke 1000 get. And you will see that for a moment it will come, sorry, it will come with different numbers. We had allocation rate, we had total request increasing, and so on. So I can repeat, for example, with 2, which also send a header name, which is my own ET counter, and this is here. So if you watch at the very end of the screen with 2, you will see that something has happened here. Okay, we have 500 with the custom header. Why 500? Because it lies across 2 different seconds, and the sampling rate here is quite low. We have many other things. So now you have seen that these counters has a right amount of the common reason why you may think that something has gone very wrong with your application. Maybe the memory is too large, maybe the number of requests is too much, maybe for this number of the requests doesn't make sense to have such a large amount of memory that has been allocated. And this gives the possibility to have triggers. Let's go back to the slides. So since these are triggers for our diagnostic, we want to go further. And what can we do? At the moment in which you detect that something has gone wrong, and it's up to you, I mean, it's not a generic debugger. So the generic debugger cannot take this decision. But if the application is yours, you know what are the conditions that are very bad in my case, and I want to trigger what? A snapshot. A snapshot is very, very close to be a dump, but is extremely fast. And we leverage the CLRMD library to capture the snapshot that does not go to the file, so it's extremely lightweight. And we can make a kind of photo, a photograph of our process in order to understand what's going on. And this you see is gray, so it's a photograph. Exactly in that exact moment happened something. What happened in that moment? And from this moment on, we have the snapshot, and we can have all the time in order to analyze what's happening. Of course, during the demo, we are not going to make any automatic analysis, but in your own made application, you can do this, and you can create reports that are specific to understand what's going wrong in your application without having to make any manual intervention. That's my basic idea. But, of course, you may want to see something and to understand how all this stuff works. And this was the reason why I created a WPF application that you will be able to access on GitHub, of course, that is able to, as a kind of front-end application, to run queries against your dump, that is, the snapshot is pretty much the same, in order to understand the reason of the fault. So let's go a little bit further and see how does it work, the trigger part. The trigger part is built upon the Microsoft Diagnostic Net Core client, and it used from many .NET tools, as we already said, and open an IPC channel with your target application using named pipes. And the way you use this client is straightforward. I mean, you create just the client giving the process ID. Then you decide what are the providers that you want to use. And you can specify many things like the level of verbosity, keywords if you want to filter out something, or even the interval of sampling. Basically the same thing that we have seen before when I ran the default tool from Microsoft by hand. And then we can open finally a session that will use one of or even more providers. So it's plural here. It's an array of providers. And given the session, we take the stream to the event. They can really consume the stream, and the event pipe, event source, process this stream and dispatch through a number of events. In this case, the dynamic all takes everything those providers can offer, but you can filter out just the ones that you prefer, of course, and you will receive a trace event. In this trace event, you will have enough information like memory, like GC count, like the HTTP requests and the client connected and many others that we well known that are well known when we diagnose using the performance counter. And finally, we run the process method. The process method, be careful, is synchronous. So you may want, for example, to do a task run in order to dispatch the execution of the process method in a thread, of course, not to block the analysis. Once we do this process, we receive a lot of counters: memory, CPU, first chance exceptions. First chance exceptions are very useful because gives you an idea of something that is weird from the performance point of view. The second chance exception are the one that crash your application, and you can trap, of course, signals that your application has crashed, but that's too late. But if you see a high number of first chance exceptions, maybe you should avoid using exception in that specific point, because first chance exception can steal you performance in the application. And also HTTP custom event counters, as I show. Let's go straight to the demo then. And this is, by the way, the repository of all the source code that prepared for the demo. This demo, so we have seen the web application, which is our target application. This is not relevant. The test console is not relevant at all. We have the custom event source that is just a single file, is my event source. I will leave this investigation from you. I mean, it's extremely simple code, and you can find many samples on the web that talks about this stuff. And then the CLR Diagnostics is a wrapper that I created over CLRMD, because CLRMD is a very good library, the 2.0, but there are many things that are not ready to use. I created a sort of utilities that give you more power for the investigation that we will see in a moment. So a lot of things were created by me. And by the way, I already contributed to the repository of the CLRMD, and I accepted a few pull requests. I will continue to do that, but there are other things that it's up to you, and you can also customize to make it even more powerful. So let's run all our things. I will stop the default monitor, okay? So the tool from Microsoft is stopped. I have the test application running, and of course I have the stress application running. Now I can, I will run from here. It's pretty much the same. This is the web application, okay? So the first option is to open a dump. If you have a file and you want to investigate over it, and we will see it later, it's okay. But if you want, you can monitor a live process, and you can see there are all the .NET processes here. I want to test. I wanted to snapshot the test web application. Okay, and be very careful in looking at here in the status bar of the application, because we will see how fast is the snapshot. Okay, run, and this is snapshotted in. I deleted in my last commit the message, sorry, but it takes like 100 milliseconds, 200 milliseconds to snapshot. It's extremely fast. So you don't have to be afraid of stopping your application that has been deployed in production. The snapshot is extremely fast. So yes, it may be a little bit disruptive if there is a very high load, but it's just 100 milliseconds, 200 milliseconds that can make a difference to understand what's going wrong. And if you trigger the analysis before the application is crashing, maybe you can recycle your web application before crashing, which will result in a better user experience for the users. So once I load the snapshot, I continue to see, sorry, I went too fast. So I was monitor the process, and of course, it's not snapshotted yet, it's just monitoring. Sorry, this is the trigger. When I go to the process, okay, I snapshotted, and give me a second. The machine is pretty busy because we have seen with Kendra that it may take a while. And if we continue to stress the application, you see that these numbers goes away. So you can monitor in real time what is happening here. Okay, so 1,000 requests for seconds, of course. And sorry, here is the snapshot. And it took quite 164 milliseconds. So I did not forget, I did not delete the snapshot, the time, sorry. So 164 milliseconds is the time that has occurred. Now I can run a number of queries. If you already know the SOS, you will know very well that there are a number of queries that are pretty standard, like the dump heap stat is already included in SOS. But I wanted to replicate this dump heap stat in my application. And so here is the query on all the memory. And you can see all the types that respond to, that have been loaded in memory. This is the method table, which is one of the fundamental objects, and the graph size. If you scroll down, they are in the same order of the SOS. You will discover that we have a large number of byte array, okay? There are 43 megs. And those are the objects, and say, what is the system byte? What is inside that? And if you open, I just added recently the hexadecimal editor. You can see if you recognize what is inside the object. Of course, there are many objects that are maybe from ASP.NET that comes from the HTTP request and will be just bloat and nothing more, and random things. But it doesn't really matter, okay? This exception that has just occurred in this moment is something that is normal, because the RST given from the HTTP client has just expired, has just come to Kestrel, and Kestrel is shooting down those exceptions, okay? So it's not a fault. I can clear the exception, by the way. And if you are going to, if you want to filter out what is happening here, I can just write the test web app is the name of my namespace, and you can see that I just filtered out everything that has the name test web app. And you see I have actions, I have pages index, and I have the view features and the generic helper containing the test web app, and so on. If instead I want byte arrays, okay, I have byte arrays, and I can inspect. But that's not the end. I mean, I have many other features. I know that I have few minutes, but you will see that it's very interesting. I can see that get static fields and with graph and sites, and this is extremely interesting because you can see that there are a number of objects that has that are statics and have a lot of objects connected. So in my query, I sum up all the objects that depends on this root. And I see, do you know that if I release this field, I free 9 megs of objects? This backfilling field, the timer queue is not 9 megs, but all the connected objects are. And this is, of course, correct, but because it are the task-related operation in my application, but maybe I can discover something that is wrong. And I want to show you the object by sides, and the object by sides give you the whole list of objects ordered by sides. And if I go down and down and down, you will see that the highest numbers are here. Now, what can I do? I can do a free leaks, okay? Once I free the leaks and I GC collect the stuff with 8, and I can again leak, but with the graph, that is the number 6. And you can see in the working set is going on, and the last GC lock is working. So I am leaking with this. And I can recapture again another snapshot, and you see that 86 milliseconds. It's extremely lightweight. And so I can go to the object by sides, and you see that I have other objects here, okay? And I can filter out all the objects that are not in the system namespace, nor Microsoft, and so on. And what I discover that even if the size, many of these objects are small, they comes from my own namespace and my own objects. So I have a graph root that keep 32K of an array with a large number of objects that is making a leak. Deciding whether it's a leak or not, it's up to you. It's your application. You may know or you may not, but you have the possibility to trigger with the kind of analysis that you desire. Another way to discover problems is going to the roots. The roots are the very basic objects in your application that may hold something wrong. And so these are the objects that keep all the graph and the garbage collector relies to in order to keep the objects in memory. Otherwise, they would be released in the next collection. In this way, I can again filter out a few things, and you will discover that I don't have anything in the roots. Why? Because a lot of time the roots are lower level, are not something that you have directly, that you hold directly, because statics, for example, the static fields are not directly roots. There are objects in the CLR that are helping you to keep the statics. This is the reason why non-system object by sides is my best friend in this case. And also you have other queries like modules, you have other queries like the threads that are running, and you can inspect all the stuff. I have to run for this application, so I want just to show you the very last thing that is very new. I just added it to my application. I captured a dump made with an application running with .NET 5 that has a new capability now, and an add-in that is loaded in the different application load context. The assembly load context is something that is new in .NET Core 3 that replace the idea of the app domain that can be unloaded. So if you unload the assembly load context, you unload all the stuff that is inside it. So all the assemblies that are there. But how can I know if something is wrong with my allocator? Has my allocator be released correctly? I can group all the objects that are in memory by allocators. And the default allocator, of course, is all your application. But I had an add-on load context that is called add-ons. And believe me, taking this name was not easy at all. And I had to ask for a special request to the friends of the CLR team. And they added it in the most recent build of .NET 5. And we finally can understand which is the allocator that is holding the objects that lives in the separate load context and that has not been released. And this is really a great feature that has been added. Finally, you will discover, and I will let you can go by yourself in watching how the queries are done. I organized these helpers, all the queries as a matching method in this library, and you can see that they are just link queries. So the beautiness of this, you can add as much as queries as you want that are built using the link query concepts. And this is extremely powerful. So I structured this analyzer in order to be queryable, in addition to what the CLRMD already provides. So the great news is that the new release of CLRMD 2.0, and in a few maybe weeks, months, we will see the next release of 2.1, is a diagnostic library to understand what's in the process of that we want to analyze. It's an extremely powerful library, but I want to stress you that it's extremely important to use it programmatically. So my WPF application is a kind of proof of concept of what you can do, but it's not really meant to be used interactively, even if it's powerful. I realized going on and adding more features that is more comfortable in comparison to analyzing something with DBG, of course. But the top power, the use case that I have in mind is putting in production, side by side with your target application, the diagnostic application that can continuously monitor your deployed application in order to understand if something is going wrong, and from that moment, capturing the exact moment. I made also a request to the CLRMD team to be able to transform a snapshot in a dump. Why? Because when you once you have the snapshot and you detect that something has gone wrong, you may want to save the snapshot on disk, and this is not currently possible. You still need to create a dump for that. If you want to save on file, you have to go with the dump. But the snapshot is more lightweight, and I strongly recommend this for diagnostic purpose on the fly, of course. All the stuff you have seen are basically the same you can use in SOS, but manual diagnostic is hard, of course. And the information retrieved are all the stuff that you can imagine on the CLR itself, on the metadata, on the log history, the modules, and so on. There are even more specific stuff on GC investigation or on COM, if you use COM. I didn't put any query for that, but there are many other possibilities that goes far beyond the queries that you have seen in my demo. What's next? CLRMD 2.1 is the next release, is going very good. One of the things is the conversion from snapshot to dumps. The known limitations are going to be addressed. They are all on GitHub, and you can take a look there. And then there is this Microsoft Diagnostic Runtime Utilities that is meant more or less to be something very close to what I did, but there are not so many queries at the moment. So there are, on my repository, you will probably find much more. I strongly invite you to follow this big event of .NET Conf 2020, because .NET 5 is a huge release. Even in the space, in the diagnostic space, there are big improvements that you will probably not find in the blogs, because they are, I mean, kind of specialistic stuff, but they are huge. I mean, I am a big fan of all the low-level stuff, and I invite you to continue the conversation. I will be on the stream on YouTube, and in order to answer to your question, if you have any. Thank you very much for being in my session. I am, again, if you want to watch the offer on Amazon or on PactPub, that's the book, and that's it. I'm done.
Hey, yeah, that was great, Raphael. I think a lot of things to cover. I think you need to come back again for like 2 hours.
Oh, it will be my pleasure, of course.
Yeah, we'll definitely get you arranged with, and definitely want to talk about your book when you come back, and what are the futures in there, promote that. So please, let's we are running short on time, we are behind, but we would love to have you back for longer time and also talk about your books and everything else.
Oh, I have many topics to discuss, so feel free to continue the conversation at any time.
Yes,
Awesome.
thank you, Raphael. And
you're welcome.
Once again, thank you for being part of the community here at CSharpCorner. Let's get ready to invite our next guest, Alan O'Neill, the head honcho at DataWorks.
Hello.
You see, look at you all there in the heat. I can see the sun coming in across May. I can see Mahesh has shaded himself from the sun, and I'm wearing a hoodie.
Where are you joining us from today, Alan?
I'm joining you from the cold part of the furthest place out in Europe, which is Ireland. And if you go to the edge of our island and walk off, the next stop is New York. So that's as good as it goes. Yeah. So the last time I was on, there was all these amazing people, and I was wearing shades and stuff. And I'm not sure if I was wearing my really cool headphones or not. These are a recent acquisition. The only problem with these is that when I'm on and I start talking and I have my green screen thing, you see this white thing behind me, and I was wondering, how do I stop this? And I was going to get some blue paper or something and put it behind, and then it makes it kind of cool, And eventually I said, no, what I'll actually do is I'll just turn these upside down. So I'll turn them like this, and then I'm like some kind of hip DJ or something. And then because you guys are coming in from the States, and I spent a number of years working in the States down around Texas, and I love Texas. And I know that Dave is up in California, and he has one of these too. So this is the best I can give you. This is my cowboy hat.
Wonderful.
Nice.
Yeah. Now what actually happens? It's an Australian hat, but it's the nearest thing I have. So that's the best gimmick I can give you today, I'm afraid.
Awesome. Well, we are excited to hear what you have to say today, DJ Allen.
Okay. Let's rock and roll. Actually, talking about DJ and music and rock and roll, we have some very fine musicians in our developer community, not least of all who is our guitar-burning hero, Rockstar Dave, right? And he and myself and a group of other engineers who also play instruments. Some of them play them really badly, like me. We've done a new jingle for Dave's CSharpCorner rock show, so that should be hopefully coming out in the next week or so. So you'll hear that, and you'll hear a line that I kind of made up, but I didn't play it because my hand was too sore. So one of my colleagues did it on his bass, but it's awesome. So rock on. I am going to crash in the next 30 minutes. I'm going to play catch up, right? And I'm going to bring myself down to quicker than I was to make sure that we catch up. So I want to cram a lot of stuff in. Is my screen jerky there on the display, or is it okay?
Yeah, I think so. It was there, yeah.
So you're good on that?
Maybe you want to stop sharing it and then start sharing it again. Okay,
let's try that. So what I'm actually going to do is try the share, and we'll say share screen, and I'm going to share the complete screen. And how does that look?
That looks great.
Yeah, is it? It's not, because it seems to be shaking on my side for some reason. Okay.
No,
all right, you guys go away. The stage is mine for the next 30 minutes.
Take it away.
So let's bang on. Okay, I'm going to also stick a phone here in front of me, so I know roughly what time it is. Now, some of you were with us before for the last conference, and I talked a lot about Kubernetes, and I'm doing an awful lot at the moment on very, very big data with millions, hundreds of millions of messages floating around systems every day. And it's all based on Kubernetes, and it uses a nice bit of AI to keep things moving along. So what I'm going to do is I'm going to talk through the fundamentals again, because they're very, very important to know these fundamentals when you're trying to this kind of systems at these levels. And once you know that, then you can pull them together, and we'll start talking at the end about some patterns and stuff. Briefly, I'm an engineer. My company is called DataWorks. We have some really cool people working for us. In fact, one of our other fellow MVPs currently works for me, Nishu Goel. And you've heard her speak on some of our conferences, both in person and virtually. So it's great to have her on our team. And it's great to be able to be in such an awesome community that we can recognize great people and reach out and work together, not just on a community level, but also professionally. So that's pretty cool to do. My message to you today is going to be all about big data, and it's going to be about Azure and Kubernetes and AI. But the overall message that I want to always push home is, guys, girls, watching this, you all know something that somebody else doesn't. Please share that with others. Please give back to your community, write articles, speak online, go to the local community meetups when they are backing up and running again. The CSharpCorner community gives out so much to people, and it's time now for everybody to start giving back. Knowledge must be shared for the good of everybody. So do your very best to give something that you know back to the community. And just because you think it's been said 100 times before, trust me, the way that you say it, your voice, your long tail, it's unique. So please get up there and step up and start sharing and helping everybody out. That's how community continues. Okay, so what we're going to do now is we're going to talk in our agenda about two separate things. We have, first of all, a recap of at breakneck speed at this stage of Kubernetes, the history, the background of containers, the fundamentals of how it hangs together, and the Azure Kubernetes service itself. And then we're going to talk about scaling to 1 billion event messages and events per day, and how I build systems to do that. And we have a number of systems in production right now doing that. We're going to talk about the lessons from legacy systems, the problems that we faced and that you will face, different scaling patterns that you need to know about and you need to handle to make sure that you push forward. And then some simple things that you can do with AI that are actually incredibly powerful when you apply them across your entire system stack. So the very first website that I was involved with way back before most people even knew what a website was in 1990 or so. And at the time, the project was absolutely huge. And I mean really, really huge. You wouldn't think it. If you look at some of the websites that are on the screen there now, that was one of Apple's original ones from around 1990, mid-90s, and the one underneath that then is Microsoft. So things have obviously changed a huge amount in the meantime. The system that I was brought in at that time to start up was a very early web system, and it literally looked something like that there. The thing was hugely expensive to get up and running. Overall, it cost us nearly $1 million back then, which was the equivalent of maybe $3 or $4 million now, just to get this incredibly small system up and running. And we didn't have the cloud. The best we had was 128K ISDN modems coming into the building. So it was absolutely huge at the time. And the thing about the difference between then and now is that whereas back then it was an absolutely massive project to pull all this stuff together, and it's actually quite interesting, and we'll talk about this another time with Mahesh, because we're currently looking at the CSharpCorner system, and we're talking about optimizing it in the background. And when you look at the amount of money that people spend over the years in these types of things versus what you can do now, especially when you're trying to do something at scale, it's absolutely phenomenal. So previously, it cost millions to get in a very small, simple website up and running. This is what we do these days. We go into our system and we go, file new website, bang, and we're off and running. We have a new cloud service. It literally is that easy. And you can push out a website, as we know these days, that'll cost you less than $1 a month to run. So all of those pain problems that we had of FTPing the code and DLLs and supporting files and everything else up to your server host, and then begging them to allow you to include some very particular permissions to run your DLL or your ACX, etc. All that's gone, you know, and you don't have to worry about the support and everything else. It's just file new website, cloud publish, go. So the way this stuff started off, again, for a recap, is we started off saying we have these physical machines, and how do we get from the stage where we had these physical machines up to what we now have cloud functions and serverless, which is the basis of Kubernetes, which is what is used, for example, to run big, massive systems like we have at Facebook, at Twitter, at Google, at Microsoft, etc. So how did this all emerge? So we started out, first of all, with physical local servers, and they were directly connected to the web. And when you go into your office, or you sit at your home office now at this stage, you have your physical computer and everything runs off that. And at the time, you know, you were there and you had to have a physical server inside in your office, and you connected into it and everything else. And you could do pretty much what you wanted. You could go in, you could run everything as administrator, you could take all those different risks and everything else. And you could have full control. And the problem with that is that it was only being used while you were there. Other than that, the systems were sitting there. They were not being fully utilized. It was wasteful. It was expensive. And most importantly of all, you were the god of that system. You were the one who was left to manage the entire infrastructure, not just that one single thing that you built. So then someone came up with this idea of renting out the rack space. And there's actually a company, right, called Rackspace that do this stuff now, and they have done for many years. And the concept was that you would bring your server physically along to them. They would put it into their rack space, and you would use that, but they would manage the servers for you. So the thing is, it's still your server, but they take care of patching the machine and making sure that it stays up and all that kind of stuff. But it's still not very efficient. So the next step up then that we had was the evolution of things called shared servers. And this was where the Rackspace hosting company would have their own hardware, and they would effectively share that with you. And by sharing it with you, it meant that there was somebody else also sharing on that particular system. And so if something went wrong on their system, because you're sharing the same server, the same hardware and everything else, invariably something would go wrong with your system, and your system would go down the same as everybody else's. So what we do in this case is we move along to the next level, and we come in then to virtual servers. And some very clever person then came along and said, okay, what we can do is we can have these virtual servers things. So we can have a physical piece of hardware, but we can slice it up inside the hardware, and we can have a virtual server that is exclusively to one person. And this means that you can have your one web server on its own, and if something goes wrong, in theory, it's not going to affect the web server or the service that somebody else is using. And that was a huge advance, but it's still incredibly wasteful, and it's still incredibly expensive. So the next major step up was the move towards containerization. And what container technology allows us to do is to create an isolated block of resources within a machine, be that virtual or otherwise, and to share the underlying machine resources without bleeding into other services that are using those same resources. So in effect, it's like a shared server, but without the side effect that one would normally have. But the problem is, if that you're trying to do something custom, etc., and you're doing it just off in one container, you've got to make sure that you manage that incredibly carefully, so that everything is distributed evenly, etc. And the next move up then from simple containers was functions as a service. And what this basically says is, okay, you have a container sitting there, but you've got to build up this container, and you've got to go and define your Docker file, your Docker Compose and everything else, and you've got to manage that end of things. But what if you're actually not building a full application? What if you just have one small thing that you actually want to say, well, whenever this thing happens over there, I want that piece of code to run? It's not critical to your system. It's kind of like sitting on the outside, but at the same time, you do need to deploy it. Should you have to go off and create a new system, a new service, a whole new container and infrastructure just to put that one function in? And the answer is no. You can have a function as a service. And that's where things like Azure Code Function or Azure Functions come along. So instead of having to go off and build up a service, you take that one piece of code you want, you host it up there, and then it's shared within, as a microservice almost, within the Azure system, and you don't have to worry about it. You don't have to worry about building a service around it. You can literally go to the web front end. You can cut and paste in some C# code, some Python code, etc., and you give it an endpoint. And when that endpoint is hit, bang, your code goes off and runs. So having that in there is absolutely huge. And what it brings then to mind is the concept of, well, if we can do that, suddenly we're no longer talking about the issue of what do our machines cost us, what do our containers cost us, what do our systems cost us. We're now saying, what do our functions cost us? So we can see what is the most expensive function in our system, and then we can go and we can work on those at that particular level. So it gets very, very finely tuned indeed to what we want to do. So we're going to talk now about the interaction between Kubernetes and containers, because at the end of the day, underneath the hood, things like functions and functions as a service and Azure Functions, they all run inside specialized containers. So let's focus on these and Kubernetes again, and how these are the building blocks of big, massive, global scale systems, which are the likes that we're currently building. So the job of containers, as we've seen, is to isolate an application and to package all of the dependencies that the application needs into an isolated, nice, tight bundle, and then to run that inside a self-contained, isolated part of the system. So if Docker manages the applications themselves and the communications between the applications inside the containers, well, then what Kubernetes does is it manages the orchestration of those containers. So even though you have all of these trains on a railway moving around independently, just like our containers, at the same time, you need to have somebody in the control box deciding what train goes on what tracks. And that's what Kubernetes does. So if you think of it another way, if you think about our services as being individual musicians in an orchestra or in a band, well, then Kubernetes is the conductor who sits at the front of the orchestra and manages everything and makes sure that everybody is playing their particular tune at the right time so that everybody sounds beautiful together and that nobody is out of sync and nobody is out of time. So if we think of it that way, it works very nicely. So the thing about Kubernetes, guys, is that Kubernetes is actually hard. It's an incredibly popular system. It's used in thousands of organizations across the world. Some of the very, very biggest organizations in the world rely on it 100% to run their systems, but it is hard to run. It's hard to set up, and it's hard to manage. And if you want to get into the real nuts and bolts of Kubernetes, and you're a bit of a masochist, feel free to go to Kelsey Hightower's GitHub page there at Kelsey Hightower /Kubernetes the hard way. If you bingle it up, you'll find it. By the way, what's bingle? Well, some of us like Bing, some of us like Google. Sometimes one search engine is better than the other. So instead of committing yourself to saying Google or to Bing, instead what you say is I'm going to bingle. So if you go and bingle up Kubernetes the hard way, it'll bring you right into here. And it'll tell you exactly how you can go give yourself brain damage for the next 6 months if you want to, learning the absolute bells of the ins and outs of it. Kubernetes is hard. It is hard to do, and it's hard to do correctly. And this is why we have Azure Kubernetes Service. One of the founding and operational developing engineering fathers of Kubernetes, Brendan Burns, leads the AKS development environment inside in Microsoft. And to say that the guy has a head like a small planet doesn't even touch it. Some of the stuff that he does is absolutely mind-boggling. It's quite brilliant. And he's in charge of this, and he's one of the founding fathers of it, so it's in very, very good hands. And in a nutshell, what AKS or AKS does for us is it takes away the pain, and it does everything for you. And that is so important. It ensures that the virtual machines that sit underneath your containers stay up. It will also scale them or auto shrink them, and it'll keep your system healthy. Just 1 second. I'm actually in my office here, and I've got my dogs with me. So Lola, you're to be a nice girl and stop barking and giving out. Now go and lie down. Good girl. So moving on, the key benefit to AKS, like most of Azure, to me, is the very, very tight integration that we have between all of the other Azure services that we love. And if you remember there, earlier on, I talked about the fact that we have to have all of these numerous other people involved in our processes to make sure that we get our application up and running. IT pros, DBAs, security guys, and everything else. The bottom line is that this all now can be tightly and utterly simplified and integrated in the overall Azure DevOps pipeline. So when you're thinking about deploying, you're thinking, oh, I can go and manage this for myself. Think about the headaches that are there down the road and think about how much pain this takes away, and you'll see the benefit of it. And at the end of the day, to go and deploy something for Azure Container Services, in the same way as I deployed a website earlier on by just going file new website and then cloud deploy, is just as easy inside any of our systems. It's easy to deploy, and it's easy to scale. We can set the system to say if it comes under pressure, if it needs extra machines, go and dynamically add more machines, and we can say how many machines we want. We control our budget, and that's very, very important. Now, here's the key. Kubernetes and Docker, they are the building blocks to allow us to automate to scale, right? In this day and age, there's no point in even trying to do it any other way. Kubernetes and Docker are the absolute winners in this particular space. But they're hard to run, and they're hard to manage together. Therefore, the very, very best advice for you guys is to ensure that you use Azure Container Services or a similar orchestrator to make sure that it manages for you. It is the pain removal part. It's not easy to operate Kubernetes on your own. It is hard. And at the end of the day, when you go and let the platform do the heavy lifting for you, you allow yourself to focus on what actually matters, and that's adding value as an engineer. The bottom line is that the AKS service is not expensive. It's not in any way costly. In fact, it's free. And we like free, right? The only thing you have to pay for is the underlying virtual machines. So it's very much worth your while going in, checking it out, and using it if you're trying to operate at scale. Okay, so now let's move on to the second part of our session. And what we're going to do is we are going to talk about lessons from legacy systems that we've learned. We're going to talk about problems that legacy systems taught us that we have to overcome. We're going to talk about some scaling patterns, and we're going to talk about integrating AI into our systems to help it all work and zoom together. So, and we still, and I'm just going to check here by zooming back into the guys, and Stephen, you can tell me how we're running on time there. How long do I have just before I continue on? He's going to ping me there now in a second. So I'll start moving on while he talks up. So in the old days, the main solution that we had to scale was we'd throw metal at it. That's the term that we use, was throw metal at it. And we'd say, if you've got a problem with scale and there's more people using your website, well, just add more RAM. Give it more CPU and just throw more processing power at the thing. But the problem is that this has some very, very severe hard limits. And there's only so big a single machine you can get, right? And there's only so much you can do on a single machine. So what you need to be able to do is you need to say, well, actually, we can't do any more what's called scaling up. Instead, we need to scale out. And that's the biggest lesson that we're going to talk about here now, is that we need to scale out. So the main lesson that we've learned from legacy systems over the years is not to use the pattern of scaling up, not to keep throwing metal at things. Instead, we use containers to contain our system logic, and we scale out. We spread the load. But there's another legacy issue that we also need to consider when we are talking about trying to scale up our systems, and to make sure that we can handle these hundreds of millions and billions of messages and events per day. And that is the huge, big, bloated, monolithic system. And everybody has dealt with these at some stage. And when we design systems, these systems generally grow and grow. Okay, so they just get out of control and they just keep gathering forward, and it's a major pain, right? You don't want to be the one who's on pager duty and gets called at 2 a.m. to go and fix the system because you've had a sudden surge and everything's going crazy. So the thing is, the way we used to be building systems, and we were taught to build systems, was that everything should be, tightly put together. Everything is in one application. But the problem with this is that it's very, very difficult to scale that system out. It's difficult not only to fix issues when they happen, but it's also difficult to even see where the bottlenecks are in the first place. And for this reason, it is critical that you take your big monolithic system and you spread it out into a series of services. So when we work at scale, we always need to think to ourselves, how can this thing break? If there is right now, 100 messages coming through, and on my system it works great and it looks fantastic and everything else, what if there was 10,000? What if there was 10 million? What if there was 100 million? How is my system going to react? How can I ensure that I don't lose data? How can I ensure that the system can manage itself and that it can shrink and grow dynamically as it needs? So we use a number of patterns to help us do these types of things and to help us meet these different challenges. So the key patterns that you need to know and you need to keep in mind when you're working at scale are to use messages and message queues and systems. Why? Well, the reason is that rather than saying, I am here with my command for my next service right now, and I'm going to shoot that across on a REST API, and it will take care of it, and we're done. You got to say to yourself, well, what if that message gets shot via gRPC or via REST API or something like this, and the system that takes the message and acknowledges that it has taken the message, what if it goes down? What if it dies? Okay, so you've lost a message. You've lost an event that's meant to happen in your system. And while that might be fine if it's maybe, you know, somebody loses something out of their shopping cart, or somebody has to click again to add a friend on their social network system. What about if it is a medical system and it doesn't add that particular drug to somebody's prescription? What if it is a banking system and it doesn't send out your wages, right? So you don't get your salary because some system went down over there. Well, who cares? Well, you're going to care, right? So the best way to deal with this, the best pattern to always bear in mind, is that when you are dealing in scale, you must deal with the message queues. And the reason is playback. When you send a message to go and do something out to another service, out to our workers, it goes and you expect it to do that. But what you say is, if it doesn't come back, what do I do? Well, it's simple. Because I have it in a queue, you simply say, go and replay that message. Go and do that message again and again and again until it gets done, or until you have a certain timeout, etc. That's your own business logic. The second thing that you have to ensure is that your data is replicated in a number of different locations. You can use Azure Data Management for this. There's a whole lot of different ways of doing this. You can use a system like Kafka for your message queue, or Pulsar, that can handle replicated messaging. But the most important thing is to make sure that you have it turned on. Make sure that when you put a message into your system, it's not depending on one hard drive. It's not depending on one machine. Make sure that that message is distributed across a number of machines, so if something goes wrong with your system, it can be recovered and picked up again. At the end of the day, the real key to all this is that you need to utilize these patterns to be able to auto-recover. Because if you don't, you're going to be in a living nightmare, and that's guaranteed. The very most important thing to implement when you're building a system at extreme scale is a disaster recovery pattern. And this is not just like, oh, my disaster recovery for the entire system. It's for every single service, and it's for every single path that every message in your system goes down. You've got to know what's happening at all times. And you must have a strategy in place that if any particular part of the system goes down, well, then the rest of the system can continue. And if something does go down, well, then it can gracefully recover. And the picture I put in everybody's mind when they start working with very large systems and distributed systems, and working with millions and billions of messages and events with big, large systems, is quite simply, you need to think Phoenix all the time. The phoenix is this infamous bird that when it dies, well, then when it goes into the fire, it rises from the flames, okay? The message here is that when you're building a system at scale, you must expect your system to die. You must expect your system to fail. And you must build in resilience against that failure from day one. This is one of the biggest patterns that you must have in your system. It must be able to auto-heal. It must be able to pick up from where it left off if something went wrong. You must not lose data. You must not lose messages. Now, we'll have quiet there, please, doggies. We're nearly finished, so let's be quiet. So the last thing we're going to talk about here is integrating AI. And this is the magic part, right? So how do we use AI in our large-scale system? At its very simplest, we can use AI to observe patterns of events, such as, for example, a message queue starting to go slow, or it might get backfilled and message events not existing for workers or for other processes to pick up quick enough. And this can be generally hard to detect and can be almost impossible to predict unless you use some kind of AI or machine learning. And one of the easiest patterns to use is simple regression. And I know that if you've listened to some of Stephen's shows on YouTube, he's gone through some of the AI stuff and he explains regression very well. So you should wind back to those if you're not sure about it, and he'll teach you something about it. And with regression, what we do is we monitor some known key metrics in our system, and we use those to predict if the numbers or the metrics that we're monitoring and observing right now, if they continue as they're doing right now, how is that going to impact the individual service or indeed the entire overall system? And when you integrate those types of simple bits of AI into your system, suddenly you're able to predict the future. And if you're able to predict the future when you're handling billions of messages per day, it means that your system can be resilient and it won't fall down. So that's the bones of the messages that we have for today. It's the end of our session. I've cut it as short as I can. There's a huge amount to cover, and we've barely scraped the surface. If there's interest, as I think there probably will be, we'll do a much longer session that goes on a deep dive into some of the topics that we discussed. And one thing that we might also look at is having a kind of a sort of a panel discussion around this type of thing, where folk can come in and ask the particular questions that they have, and then other people who have had experience of this type of thing, be it AI or huge big systems, et cetera, can start answering questions and helping others out. So I'm going to unshare my screen now for a second and go back into the main dashboard. And what I will also do, just for the fun to end it up, is Lola, come here, because she disrupted us. Okay, come here, little bird. Come on, come here, Lola. Come here.
Whoa, magic!
Now, there's Lola.
Wow.
Aww.
Just to keep her head there.
She's beautiful.
Adorable.
Now, she's a good girl. She's also the boss of the house. She keeps everybody in control. Yeah. So there you go, guys. I hope that we have almost caught up on time and that it was useful to everybody. Anybody, any questions that you want to throw out?
Well, that was great. I think questions we will, there's a lot of questions. I think we should do is plan for a next longer session, as you said, also some Q&As, more like a panel. That's where we want to do more. But looks like this is a topic, architecture and / all these scalabilities that you can spend all day, right?
Absolutely. We could talk about this all day long and get very drunk.
Yes, definitely.
Thank you, Alan, and thank you for joining our community here at CSharpCorner.
You're very welcome. Thank you for the invite, and back to you guys.
Yeah, it's time to welcome our next guest, Daniel Costea, Microsoft MVP on Developer Technologies.
Hey, Daniel, welcome to the .NET conference.
Hello. Thank you very much.
We are very excited to hear what you have to say, Daniel. And I thank you for joining us once again. The stage is all yours whenever you're ready.
Thank you. Yeah. I'm a senior .NET developer and the Microsoft MVP on Developer Technologies. And I will tell you a short story. I remember when a couple of years ago, I had to prepare a material for a conference. The topic was about exemplifying the coolness of .NET Core on IoT devices running Linux. Of course, I added some sensors to my Raspberry Pi, and I started to get data, more and more data. And you know, the larger the data, the bigger the chaos. And at that point, I have realized me and new ML.NET framework can do a great job together. Then, bang, the first problem hit me. I'm not a data scientist, nor planning to change my career. I love .NET. At that point, I had a very vague idea of what machine learning is, close to zero. Big dilemma because we as developers, I think I lost the sharing phase.
Yeah, Daniel, I think your screen is not shared. I was just going to drop into the live show.
Yes.
Perfect.
Not too much data
there you go.
you missed. So the problem was I'm not a data scientist. And the new AI paradigms are going to change the way we code. Just take a look at C# language. We started primarily as an object-oriented language, and how it embraced functional programming more and more with each major iterations. Traditional programming is all about dropping some input data into an algorithm coded step by step by us and getting the output data. On the other hand, in machine learning paradigm, the data goes in as input and the algorithm comes out as an output. Isn't it wonderful? We are so into the algorithmical way of programming, we don't even realize it. We put our intelligence in code, and that's pretty rigid. Why not rely on the machines to create intelligence? In the end, isn't it this more human? Coding is not more human than learning. Learning is failing, succeeding, repeating until we learn the rules, right? And this is not rigid at all. Very tempting, indeed, but this will not solve all our problems, at least not yet, maybe in the future. In the world of data science and machine learning, Python programming language is making the rules. In addition to that, the existing frameworks like TensorFlow, Keras, Torch, CNTK are not easy to integrate with .NET projects. ML.NET is built upon .NET Core and .NET Standard, inheriting the ability to run on Linux, macOS, and Windows, and is designed as an extensible platform. Therefore, you can consume models created with other popular machine learning frameworks or deep learning frameworks like TensorFlow, CNTK. Microsoft.NET is more than machine learning. It includes deep learning, at least the inferring of the models, and transfer learning for now. We hope for more in the future. And we have access to a large variety of deep learning scenarios like image classification or object detection. Let's see what is it in it for us. Well, when I first have to deal with machine learning, I soon realized finding the right trainer for building the model is not the hardest part. As a proof, very soon, Automate ML was released, which is a way to guess which is the best trainer for your problem according to the measurements of the model quality. The hardest part is to get everything ready for building the model, and that's data. A machine learning model is as good as its data. That means a bad data set drives to a bad model. Actually, a good data set is better than a smart algorithm. So be very careful when preparing the data, because your data contains your biases. If you decide to save time preparing the data, do not be surprised you have to pay the price later. I'll say it again, do not skip data preparation. You will waste a lot of time and not in a productive way. This is similar to technical debt. And so I would call it data preparation debt. Usually, the building model flow is something like this. Load data, visualize it, analyze, prepare the data, build a model, and then in the end, predicting the data. If we skip the data preparation to save time, or I don't know, maybe because we are beginners, we will not understand what we are doing. Been there, done that. All I could see was the magic of machine learning, like a black box or black magic. I'm not saying having a simplified flow is always bad. I'm saying when building for the first time the machine learning model, you have to follow all the steps and get important insights like metrics. You will use this information for tweaking the machine learning model performance later. First thing first, loading the data. But let's analyze a data set. A data set is consisting of observations, which are collections of lines with features. We can call it a reading. My use case for this demo of this talk is supervised learning. More exactly is multi-classification. I'm telling you that because part of the demo, it's relating to multi-classification. The word supervised comes from the fact that labels need to be assigned to data, to reading, by a human supervisor, usually a human. Maybe in the future, this will be a machine as well. Actually, I have another talk which try to combine, to mix deep learning with machine learning on this topic. But let's see how we can load some data from different sources. SQL data. In the future, we will be able to load data from NoSQL sources as well. But for now, SQL Server is one of the sources. Or MySQL, or PostgreSQL. Then it's CSV or TSV data. Usually we will deal with this. Then it's images or binary data. For example, for deep learning, we rather rely on loading images. Please take note that data loaders, transformers, savers, trainers, estimators, predictors are all working with data views. Data view is a native way of manipulating data in ML.NET. It's a native object. I will get into some details in a bit. So now we have data in a data view. Let's visualize it. But first, what's data view? A data set in ML.NET is represented as a data view, like a table with rows and columns. A data view is an object being able to gracefully and efficiently handle high-dimensional data in a large data set, larger than main memory, and think about 100 or 1,000 of megabytes. Like views, like the views in relational databases, a data view is the result of computations over one or more base tables or other views. And a data view is generally immutable and lazily evaluated, and that's very important. We will see why. Data view has schema with collections of columns and rows, and it has metadata or annotations. And maybe the most important and beautiful thing, it's composable. A data view is composable. Does this ring a bell? Most C# language improvements for the last versions are improving the language in this direction. I mean, dealing with data. Objects are cool, but we need to process large data, and we need to do it fast. Starting with extension methods, lambda expressions, value types, matching patterns, immutability, and now with C#9 records, which are actually classes dedicated for data. We all have these things competing for dealing with data. Indeed, when we deal with machine learning, we drop into the building pipeline a lot of data. And we need to do it as fast as you can in terms of code performance. Otherwise, we have Python. Oops, did I set it? Again, data loaders, transformers, savers, trainers, estimators are all working with data views. Load from text file is just one way of loading data into a data view. And now we have data in a data view, but data view is lazy loading. How can we visualize it? How can we visualize the data in it? One way is to convert it to IEnumerable. Another way is to use another object. It's data debugger preview, which is recommended only for debugging, hence the name, data debugger preview. A more professional way is to use data frames. What's a data frame? Well, data frame is part of Microsoft data analysis library. And if you are familiar with Python, you can see this as similar to pandas. Data frame is immutable in-memory representation of structured data stored as collections of columns and rows. No surprise, right? Data frames support a series of operations, computations, joins, merges, handling missing values, adding or deleting columns and rows. And there is something more. The printing format can be improved using object formatters and the Pocket View API. Think about Pocket View API as a lightweight HTML renderer, something like Razor. For example, we can use object formatter to render more complex data in a friendlier way, like this navigable table, which I have contributed to the official library, Microsoft Data Analysis. And I think this navigator will be, this browser will be integrated in the next release. DataFrame was released less than 1 year ago, so it's a work in progress and a good opportunity to contribute. Because there are a lot of things to do, not very complicated. Okay, now we know what's a data frame, but let's see what benefits it brings. The basic question about the data set is how many observations and features we have. What's the data types? Are they numerical, categorical? Which is the label feature? And the purpose of displaying examples from the data set is not to perform rigorous analysis. We don't need anything exact. Instead, it's to get a qualitative feel for the data set. Do the columns or values make sense? Are the values on the right scale? Is missing data going to be a problem? What about the outliers? Are they errors or not? Now, because we are getting closer to jump on the demo, let me introduce you the tool which we'll use to do our job. Python users have Jupyter Notebooks, which is a great tool. And we can integrate Markdown code with code and with diagrams. I mean, C# code, F# code. Until recently, ML.NET did not have a good read, eval, print loop tool to play interactively with code and data. But now, .NET developers can run on-premise interactive machine learning scenarios with Jupyter notebooks using C#, F#, PowerShell, JavaScript kernels in your web browser, or even better, and that's pretty new, in Visual Studio Code. In this very moment, it's available only in Visual Studio Code Insider, but very soon, I think it will be available in the regular Visual Studio Code. So if you want to play with it, you have to search and download Visual Studio Code Insider. Jupyter Notebooks supports commands like interrogating the system for the version, loading dependencies or libraries, loading CSX files. CSX files are C# scripts. Examine the memory for variables and their types, switching the context between various languages, C#, F#, HTML, JavaScript, transferring variables between the languages. That's wonderful. In Jupyter Notebook, we can still use console write line to print data, but we will love display command since it's able to print formatted text like HTML, like diagrams, like charts, like SVN content. Display command is built upon Pocket View API, which I mentioned before, and is consisting of C# helper methods for rendering HTML code. That means we can use it outside the Jupyter notebooks in a regular C# application. Of course, we don't understand much looking at the tabular data, but Jupyter brings up some great diagrams. The library used for this is Explot-Plotly, and that's a data visualization library able to aggregate data in a more useful way. And as I said, it's great for drawing amazing diagrams and charts. But enough talking, let's jump on the demo. So we have here a piece of code. Actually, it's a notebook. And we are running, as I said, in Visual Studio Code. So at the beginning, we are loading some libraries, importing them. I have an advice here. Wait for the icon showing the loading as far as it stops, or as far as it's not counting anymore, because I think this is a little bug and sometimes it's not stopping, like now. Then I have here an object formatter which helps us see the data in a much better way. Otherwise, it will not be able to show more than 10 records by default. I will jump directly to the diagram which I built for this. And we can see now we have here a table with the navigation buttons. So we can browse through the data, jump more data, or jump to the end, jump back. Anyway, it's a better way to see the data. Then we are loading some data from another file because I want to show you something which we can do with data frames. So I will load some data. First, I have loaded data from sensor CSV. This is a file getting data from sensors. And then, sorry, I'm searching. And then we are loading data from labels. And usually we need all these data in the same file because together they are an observation. So in order to being able to merge them, to join them, I have used the timestamp, a date time field here named created at. But that's not very easy to use, so I have to transform it in a numerical field. And for that, I'm using a simple operation here and reading the ticks from the data frame, from the datetime. Sorry. Then I'm adding this new field in a new data frame. Maybe there is another way to simply append, but I couldn't find quickly. So I'm rebuilding the data frame based on the old data frame and adding this new column. Now we can see here the ticks here, and I call that field ID because I will use this field as the key field for joining these data frames. Then I'm doing the same for the labels. You can see here the labels and the score and create it add. But let's transform it to ticks, right? Now it's merging. Actually, I hope I have run that. Otherwise, we can go back and run again. I forgot to tell you, we can run randomly any cell in this Jupyter Notebook. And now I have joined these two data frames into a larger one. You can see here ID from sensor, ID from label, and this will be the key for merging data. And I can drop, for example, the nulls, because if we see here, some fields, some data are not matching, so they will stay unmatched. For example, right here, or here for the sensors. Of course, we don't want to use that data because it's garbage. So I will clean that rows. Then maybe I will clean the fields which I don't use anymore. And at the end, I can simply save the data frame in a new CSV file. But here is a problem, because I have to write some code to put this in a new CSV. But since I have it, we can see now the new file here. Let me open for you. And you can see now this is the merge data. Okay, enough with the data frames. I just wanted to give you a flavor of it. I will jump back on the demo. And let's see what's next. So, using load from text file, or using data frame, we can get data into a data view. Maybe not in one step like the data frame, because we have to convert the data frame to list and then therefore in a collection, and then load from enumerable, which is another method which loads data in a data view. But very soon, and I hope this will be included in the next release, we will have write CSV in order to persist data in an external CSV file. Now let me show you a scenario for our demo in order to understand the context. Let's suppose we have a system able to read temperature, luminosity, infrared, distance to a source, and created data. And we have a data set consisting of 1,000, for example, observations. The more data, the better. How much data is enough? Good question. The answer is from experience. I don't have an answer, and at least not a good answer. But if you have more categories or classes, you need more data. If you need more precision, you need more data. So make sure you have enough data. Actually, if you don't have data, then party is over. You cannot even start. So these observations are labeled, and that means we have a feature source for this reading for every observation in the data set. Actually, the source from these sensors is generating these observations. These sources of data are a lighter, a flashlight, daylight, and an infrared torch. Let me exemplify. We have a data set with readings from an IoT device, and we want to predict the source of these readings, which generating these readings. Giving, for example, 24 degrees, 90% luminosity, 0% infrared, and 100 centimeters to the source. The time of the capture, the question is, what is the source of these observations? Maybe it's a flashlight. It looks like it's a flashlight which generated these values. Data from sensors can be calibrated or uncalibrated because the type of the sensors are calibrated or not calibrated. Uncalibrated means they are on a scale usually between 0 and 100. It's important to understand what problem do we solve. Here we have multi-classification, supervised learning, but depending on the label, we can have binary classification or regression in the same data set. Or maybe unsupervised classification. Look at the table and imagine a classic solution consisting of a very complex tree of if-else statements. Therefore, we might end up having 2 by n if-else statements. That's 16. But what about if we want to add another 2 or 3 features, for example, 3 features? We will end up having 2 by 7, 128 if-else statements, and that's not all. Let's suppose we are indoor and in a room, for example, thinking of the thresholds which we have to adjust in order to decide if a value is big enough or small enough to be part of a lighter or a flashlight. Well, are you done? But bad news. Move your system with all the sensors on the roof and your code will fail because the system is not calibrated for outdoor data. And you have to redefine all your thresholds and maybe even change the algorithm in a few places. Well, using machine learning, you can get rid of this. We have visualized the data, but that's more like individual values. And now let's extract some information from data. Let's analyze the data. But first, let's review the ML flow to see where and when we do that. So we did some data from the CSV, split the data in 2 data sets, training and testing. We plan to leave the testing data set untouched and use it only for validating the model. So we will play on training data set. Then create an enumerable collection. Remember, data views are lazy loaded, and they don't load before the training phase. Then visualize using different diagram types. Categorical, numerical distributions, box plot segmentation, correlation metrics. We will get into some details in a bit. For example, numerical distributions, we look at numbers. Where is the range of our data? In what range is our data? With the numerical distributions, with categorical distributions, we look at the categories of the classes. Maybe one class is too little. Maybe it makes sense to merge two classes in order to make it more relevant. Because if we have too little data, it will not help us. Actually, we prefer to have the same data in each category. With box plot segmentation, we can extract valuable information like the median bar, the min-max values. For example, temperature has many outliers. Are outliers bad? We don't know, depends. Maybe, for example, if we got the data from a sensor which is calibrated and that's from 0 to 100, having a data 120, it's bad. It's in an error. So we can clamp the data. We can limit. We can replace everything which is above 100 to 100. Then we might want to normalize the data if they are not calibrated. We can see here distance it's in a wide range, and the infrared it's in a small range. For example, now the features, take a look. The features are calibrated. Some trainers are normalizing the data by themselves, but for other trainers, we have to normalize alone if we really need to do that. Depends. Then it's another instrument. Thinking of data, another question arises. Do we really need all these features? Of course not. Some features are not useful for our problem, but we have a lot of data. Well, the more features we have, the better, but this is increasing the dimensionality of our model. Therefore, this have a direct impact on the model building performance or on the training time. Correlation matrix is a wonderful instrument to analyze this. It's possible that some features are strongly correlated with others, therefore they are redundant. For example, a quick example, if we are reading temperature from two sensors which are very close, is it relevant to get both set of data because they are varying in the same time, very approximatively, with the same precision? It's not. But correlation matrix will really show us if it's the case. Well, for us, it's not the case. We will see this on the demo, and we will see what that means to be close to -1 or close to 1. Actually, close to -1 or 1 indicates a strong relationship, and 0 indicates no relationship. We will prefer those closer to 0. Let's see the demo. First, I will run this notebook with a simple sample example showing a model pipeline which gets some data from the sensors, but very importantly, we are using about 6 features. It's temperature, luminosity, infrared, distance, personal infrared. That's a sensor telling you if it's a human or not in the front of the sensor, and humidity. Well, most probably not all of them are useful for our problem, but we will find out this soon. First, I'm using all of them, building the pipeline, training the model, calling fit method. Then I'm evaluating the model. First, I'm calling a few helpers to make things look better. I hope this will get into Microsoft Analysis Data library soon. And let's see the metrics. Okay, so we have here the accuracy macro or micro. We will talk a little bit later about that, but this is important now. Our model has 9130 micro accuracy and 9078 macro accuracy. Of course, let's predict some data with this model. As you can see, I'm dropping in a sample with the 32 degrees Celsius temperature. By the way, all the numbers are single or float. This is the native type for machine learning. So having this sample, our model predicts this is a flashlight. And it makes sense because it's not very hot, pretty bright, but not too much because I want to show you something. So the distance is 20 centimeters and so on. But let me show you something. It says flashlight 85%, but maybe it's daylight if it's bright enough. Maybe the sun just got onto your window. And now let's analyze the data. Do not forget, we try to increase the accuracy by using these instruments. So now I'm jumping on analyzing the data. As I exemplified in the presentation, I will jump quicker on this. We have here they're all together, but let's close some of them. For example, humidity, not that one. Temperature. See, it's distributed, but mostly between 20-40 degrees range. Then categorical distribution, it shows our classes, our categories. And then it's plot segmentation. Here we can see in what range is our data. We have some outliers, which are fine. But as I said, if we get outliers in data which is already calibrated, it's not good. It's an error. And let's show you the correlation metrics. We can see here if two features are highly correlated and not. For example, we can decide, looking at this, I will fast forward a little because the time is short. We can decide to get rid of some data here, some features here. I will jump back on the presentation and show you a little bit of how we are preparing data. So the raw data, it's not cleaned. We have to clean it. Therefore, we will use some data. And we have to split in two. And we drop data into the pipeline. Which data? The training data. Then we train the model. And along with the training data, we validate the model against the training data. But we can then evaluate the model against the testing data set, which is untouched data, and get some metrics and show them and see them in these instruments, which I will exemplify later. For example, cross-validation gets the training data, split it in a fixed number of folders, and it trains the model with each of these against the validation set, and it calculates the average accuracy. We can see then the accuracy here in the table. Then it's performance feature importance. For example, this one shows us which feature is more important, which varies, varies the most with the other features. We can see PIR and humidity are not very relevant for our problem. So, having this, we can evaluate the model, see how are the values here in the table. For example, after getting a model, the first thing to concern is to see the confusion matrix. This will tell you if some flashlight is seen as an infrared mistakenly because it's not perfect, and it calculates the precision. Or we can simply go to the code, and let me show you how we can do this. I'm running again. It's another notebook. We can see here the performance feature importance. Having this, we can decide which feature will stay or not. And then we jump on the last part of this demo, predicting data and seeing the accuracy, having an error set of features. For example, we decided to get rid of PIR and humidity. Let's rebuild the model. Let's evaluate it. We can see an improvement from 9130 to 9230. Our model is better. And that's because we realized we don't need all the features. So we jump back to the presentation. And I want to let you know there are a few resources which I recommend. We can see here the source code for the demo which I have used for this presentation and another work related to ML.NET. And if you have questions, please let me know.
Thank you, Danielle. That was a great presentation.
Thank you.
Yeah, definitely looks like you need more time. We need to bring you back for longer time. Just a lot to cover in 40 minutes.
Usually I have presented that in 1 hour, and now it hit me.
Yeah.
Yeah. So no, definitely we're gonna probably it's a lot of details. So definitely great session.
Yeah, and thank you once again for being part of our community here at CSharpCorner.
Thank you very much for having me. It was a very good thing. I remember for about 15 years at least, I'm using CSharpCorner as a source of inspiration. And now I'm happy to be one of your speakers. That's wonderful.
That's great. That's awesome. We are glad to have you here, and we'll continue to bringing you back.
Mm-hmm.
Thank you very much.
All right. Thank you.
All right, it's time to now welcome our next guest, S. Ravi Kumar. He is an experienced IT professional with over 15 years of experience.
Hey, Ravi, how are you? Looking sharp.
Thank you. Thank you. Thank you.
Welcome to the .NET conference. We are excited to hear what you have to say to speak about today.
Thank you. Sure.
And
All right.
without further ado, take it away.
Yeah, sure. I have shared my screen, so
We can
I
see it.
think. Okay. Okay. So hello everyone. So my topic for today's session is multi-platform web development using Blazor. So before starting, little bit about myself. I am a certified Azure Solution Architect, founder of .Code Techies user group. And if you want to search anywhere on social media, you can search me by Techie Rathor. I have a YouTube channel, blog, and GitHub page, everything by the name of Techie Rathor. So let's start the agenda. What we'll talk about multi-platform decisions. What are the multi-platform development options available? Then we'll talk about Blazor. What is Blazor? What are the options for developing Blazors and how we can develop applications using Blazor? Then we'll talk about third-party Blazor libraries currently available. We'll talk about multi-platform Blazor application architecture, how we can develop multi-platform Blazor application. And then I'll give you a code walkthrough of my sample multi-platform Blazor application. And then I can also give you the link of how we can get started. At the last, it will be questions. So let's talk about, first of all, what is multi-platform web or desktop development. So basically, multi-platform web or desktop development is when we are creating a web application, but we want to reutilize it at different places, whether it is desktop or in mobile in the form of a progressive web application or PWA, or we can create a direct desktop application. So, or we can create the web application. So when we are using the web technologies for doing this, that's when I call it, like it's kind of my definition. It's not an official definition. If you see official cross-platform or multi-platform definition by Wikipedia, they will say that it should include mobile also. But in my definition, I would say that when we are using web technologies to work on different technologies, then I can say that we are doing the multi-platform development. When we talk about current frameworks which are available to implement this, the most popular one comes into our mind is Electron and Electron.NET. So using Electron, we can develop different application. We can use different framework, like we can use Angular, we can use Vue, we can even use Blazor to develop Electron applications, and we can make it cross-platform desktop application. So the architecture which I will suggest, you can use that architecture with Electron also. Apart from that, there is Uno framework, using which you can, of course, get true multi-platform. You can develop true multi-platform application where you can create desktop and web, of course, WebAssembly based web applications, then desktop applications and mobile applications using single UI framework, that is Uno. And there it will be using XAML. So you won't be using the web technologies there. You will be using UWP XAML, the XAML which is used in UWP for creating multi-platform applications. Now let's talk about what is Blazor. So Blazor is basically a free and open source web framework that enables developers to develop web applications using C# and HTML. It uses Razor syntax, and the name is a mixture of browser plus Razor and L thrown out there. So it's Blazor. And it basically works on component-based architecture. So this is the benefit of the best benefit of using component-based architecture is that we can create multi-platform applications, of course, and we can reuse the code everywhere, like in any web or desktop application. So it can run in two ways. When we run on client side, or when we run the Blazor WebAssembly mode, it can run on Blazor WebAssembly, and the server side, which communicates, all the communication is done via SignalR, it runs on like web server. So we can use there, we use the Blazor web server, that is your .NET Core, ASP.NET Core server is used for that, the Kestrel server. And for client side, it uses the WebAssembly and Mono for doing the development. Still, it uses Mono. After .NET 5, it will start using the .NET 5. And the benefits of using both the options are there, like WebAssembly. Right now, Azure has given you another option. There is a preview option of hosting static sites directly on Azure. So you can host Blazor WebAssembly based static site directly on Azure. So that hosting benefit is there. Cheap hosting is available. It can work offline. You can call the servers faster time. And of course, first load is a bit slow, but the overall application flow is very fast. Same with server side is that it's fast to load, but it depends on your network speed. So if your servers are at a different location or a faraway location, so and there is a network latency due to your internet, so same the web, whatever issues you have with a web application, the same application you will face with the Blazor server also. Apart from that, you can of course easily use SQL Server or any kind of database directly from the Blazor server. So directly from the Blazor code, you can call the web services or you can call the SQL Server. So you can use all the capabilities of .NET Server when you are using the Blazor server. Of course, it required continuous internet connection. So this is how basically a Blazor application works, where we have the web front end, which is Blazor. It communicates with your backend. It can be a .NET or Java or Node.js based application, but it's better when we use .NET because of course there is more code reuse in that scenario. So why you would be interested in this? So the thing is that number one, C# is fantastic language. We are in a CSharpCorner event, so C# is like kind of the base. Right now, C# is using C#, you can develop any kind of application. That is the best part, that if you learn C#, you can develop any kind of application, be it mobile, be it web, be it desktop, be it machine learning. You just attended the session of ML.NET, which is again where again you are using C# to do machine learning application. You can do IoT development. So C# has many benefits above other frameworks. Apart from that, when we are using Blazor, we get ASP.NET Core performance. So all the performance benefits of ASP.NET Core are available with Blazor. So it's like number 7 in Tech Empower best frameworks list. It is 8 times faster than Node, 1.5 times faster than Java, 47 times faster than Django. So you can get all the performance what you need from ASP.NET Core. You can share the logic. So you can share the validation logic, you can share the clones. And if you use this particular architecture, which I'm suggesting, then you can even share your UI throughout your different platforms. So that is the benefit. So you can share the code logic. Then consolidated front end and back end teams. So there won't be 2 different teams, and there won't be politics involved with the teams. That okay, back end doesn't given us this thing, or front end team has not completed yet. So those all things will not be there, and you can consolidate both the teams at a single place. So Razor Pages, how does Razor Pages work? Basically, Blazor is based on Razor Pages. Those of you who have already worked on MVC, ASP.NET MVC or ASP.NET Core MVC, they would be pretty much familiar with Razor Pages. So Razor Pages basically uses the Razor syntax, which is again similar to ASP.NET MVC, where you use @ sign whenever you want to use C# features. So you can, as you can see here in the code, @ code we have used to write the C# code, and you can use you can give the conditional statement, you can use @ for each loop. It's similar to ASP.NET MVC, ASP.NET MVC page. So when you are designing a ASP.NET MVC page, similarly you can design the Razor page also. The only difference here is of course the extension. So Razor is basically .razor extension is there, and you can include the code inside the Razor page, just like as mentioned here in the screenshot, that inside the @ code, you can put the code inside your Razor page. So that you can do. So these are all the features of Razor page. This is how you can use the Razor page. Then currently there is no by default feature of Razor code behind. So like in case of ASP.NET MVC, you have like CHTML is the extension there, and then CHTML.cs is the extension for their code behind page. But in case of Razor, there is no such extension. However, if you create a class file, a regular class file with the extension .razor.cs, you can get this kind of like behavior that it will be collapsed together, and you can open it and you can move the code there in the form of, like, you can create the partial class and you can utilize that thing. And of course, this partial class would have to be inherited from component base class. So component base class is the one on which all the Razor components are based. So that's why I haven't added this screen. It's not there in the screenshot, but you have to inherit it from the component base class. Then only that code behind will be merged together with your component class. Even some people also do this thing that they, instead of naming it as a partial class, they name it as a like component counter or whatever, and then base, and then extend it from the component base, and then they inherit it in the Razor class. So that option is also there, but this is a much cleaner approach and much like cleaner to understand also. Next come, what are the built-in components? So the built-in components of Razor looks pretty much similar to HTML, and they are rendered down to HTML. So you have input text, you have button, you have check, and all the other components. You can see what all the components are there by going to docs.microsoft.com, ASP.NET Core Blazor. So there you can go on the link and you can see what the components are there. A few components listed here are like this, like you have input text, which is rendered as input. You have input text area, which is rendered as input text, like text area. You have input select, which is basically rendered as a select, which can be used to create a drop-down list. Then there is input number, input checkbox, input date. So these are all for creating different type of HTML controls. So these are the benefit of these input components or direct Blazor components are that they provide two-way binding. So you can bind them with an object, and then you can like refresh this or implement MVVM pattern or any other like reactive coding. You can do all those things by providing two-way data binding using this input date controls. Then you have navigation. So for doing navigation, it's basically a URI based navigation. So you have to use the @page directory as shown in the code, and then when you write @page/ whatever the page name you want to give. So it doesn't matter what the file name of the Razor is, like what is the Razor file name. If you give the whatever the page name you give, that would be the URI of that particular page. So that's how the navigation works basically. And you can, in the href section, navlink href section, you can give as the name here. And also you can use navigation manager when you are calling or when you are moving from one page to another in the code behind. So if you are writing HTML code, if you are writing C# code, and in the code behind you want to navigate from one page to another, you will use the navigation manager to do that. So navlinks and navigation managers are basically two ways to navigate from one page to another in ASP.NET Core Blazor. And startup and dependency injection. So dependency injection works similar to ASP.NET Core and MVC. So it registered in the startup.cs or program.cs. There you have services collection, so you can implement it, and you can also resolve the constructor with the attribute, like when you inject, you can add the inject parameter, and you can use the any kind of service, or you can use the contribute like constructor injection when you want to implement the dependency injection. So if you have implemented dependency injection in ASP.NET Core MVC, you just declare your services in the startup.cs class or program.cs when you are using the WebAssembly, Blazor WebAssembly. So you declare the services in program.cs, and in Blazor server you declare it in startup.cs, and then while using it you can just write inject, and then it will automatically be injected by the default dependency injection engine provided by ASP.NET Core. Then JS interoperability. So it's not only that you can not only use the C# code, the another benefit of using Blazor is that you can also use Blazor, like you can also use the JavaScript code which you have written. So if you are very familiar with any JavaScript library, like there are many charting libraries, like Chart.js is there, D3.js is there. So there are many charting libraries are there. So if you are comfortable with using any charting library, you can directly use that library by using this JS JS interop feature, where you include the JavaScript runtime or JS runtime, and you can inject it just like any other server and call the JS runtime invoke method. So using that you can even write the alert, call the method. So whatever kind of JS whatever JS method you want to use, you can use using JS interop feature in Blazor server or Blazor WebAssembly. Then when we talk about components, there are many third-party components also available for developing Blazor applications. So like there are all the third-party components are available via NuGet, and all the JavaScript libraries, as I mentioned earlier also, all the JavaScript libraries can be consumed using JavaScript interop. Now, when we talk about Blazor specific libraries, there are many Blazor specific libraries like Blazorize. This is the one which I extensively use. I am contributing to their documentation also, and I use this Blazorize UI framework very extensively. It's cross-platform. The best benefit is that it's an abstraction over other frameworks. So when we talk about other UI framework like MatBlazor, or when we talk about other framework like Redzen or vendor-specific Blazor libraries there, but when we talk about framework like open source framework like MatBlazor is basically dependent on a particular CSS library. So not dependent, it implements material design. So it implements the material CSS and material JavaScript and everything. Whereas Blazorize is basically a abstraction over the different design libraries. So you can use material design with Blazorize, you can use Bootstrap with Blazorize, you can use Bluma with Blazorize. So right now these three frameworks are supported, but you can use any of other JavaScript framework also, since it is open source. So you can contribute to it, you can change the component. So it's kind of an abstraction over the other CSS libraries which you can use for creating your UI framework. MatBlazor is also very popular because it uses material design, and material design is nowadays very much popular in developing web as well as mobile applications. So that's the reason MatBlazor is also very popular. But after MatBlazor, Blazorize is also very popular, and I prefer Blazorize because it gives me the option to choose from material design to Bootstrap to Bluma, whatever I want to choose, I can change it later on also if needed. So that's the benefits. That's the reason I personally prefer Blazorize. Now let's talk about the multi-platform Blazor solution architecture. So it's pretty much similar to your when we talk about Xamarin application. So it's very much similar to the Xamarin application, where we have the code, one code base which we can use for shared code logic or business logic. We can use database access that is shared. Again, both of these will be kind of your kind of .NET standard library, but you can write the shared UI which will be used by different applications. That is, you have one web head, that is web server. So when you host it on the web server, the web head will use the shared UI. When you have the WASM head, the shared UI will be used by the WASM server. or the WASM application. When you are creating a PWA or progressive web application, you can use the progressive web, the same UI will be used by the progressive web app also. And if you are creating a desktop app, you can use the same UI with desktop app also. So this is kind of an architecture which I suggest to follow, so that it can be easily extended for creating different kind of applications. So when we are starting, we can start with the shared UI, shared business logic and webhead, and then later on when we want to extend the application to the WASM side, or we want to extend the application to PWA or desktop application, we can just add another project and add the head part of it, and we can call the shared UI from there. So that's the kind of approach I suggest basically, and this is kind of a solution architecture how we follow. So like all these different heads will be basically different projects, and the shared UI will be a altogether different project. The technology or the frameworks involved in this solution would be, of course, for the client side and the server side, we will be using the Blazor WebAssembly and the Blazor server. And for the desktop side, we can use different framework, like there is Electron, there is Web Window, there is Chromely. Right now, the sample which I have created, it uses Chromely, because I tried to use Web Window, but there are still some issues with Web Window. So I was not able to implement that, but I was able to use my code in Chromely. So I have used Chromely. And then apart from that, you can also use Blazor mobile binding, or you can use Xamarin Forms. But in this case, when you are using Blazor mobile bindings or when you are using Xamarin Forms, in both the scenario, you will have to create the UI separately. So you won't be able to use the same UI. So if you want to use the architecture or solution structure which I showed in the previous page, in that scenario, of course, for mobile side, you will have to use PWA instead of Blazor mobile binding or Xamarin Forms. So what are the advantages? Advantages of multi-platform Blazor development is faster development cycle. So it's very fast to develop applications using this thing, because your UI code base will be common, your models will be common. So the development cycle will be fast, of course. Cheaper, as we can utilize existing Blazor resources. So when we are designing the UI in common Blazor project, we can utilize the same UI in the different different platforms. So that is the benefit of using. And then of course more code reusability, because we are using the code which we are using in server as well as which we are using in WebAssembly. So that is the benefit. Now there are some disadvantages also, because nothing comes with all the benefits only. So the disadvantages are, many things are in experimental mode. So if you see, even I was not able to completely implement Chromely right now. I am constantly in chats with the developer of Chromely, because Chromely is also an open source framework. So like they are supporting me, and we are developing I'm in process of developing this thing. Web Window is completely experimental. Steve Sanderson is the one who has created Web Window, and Web Window is completely experimental. He has said that he is not ready to promise that when it will be a part of Windows like ASP.NET Core or .NET Core framework, or whether it will be or not. Just like mobile bindings, the Web Window is also experimental. So that is the one problem. And of course support availability, because since most of the things are open source, especially in case of desktop application, when you want to create desktop applications, most of the things are open source, so the support is kind of a challenge. So that is one of the things which you have to think about when you are extending it. But again, in future support will be there, because this thing is growing. So support will, of course, will be there. So now let's see the demo. Let me show you how the project flow, how the multi Blazor solution works. So let me show you that. So this is my cross-platform or multi-solution Blazor application. When you see here, This is your components folder, Blazor components, and this Blazor components is the one which is the shared UI. So it has the pages, which is basically for every page in the application, and this shared section is for like shared components, the user control, this checkbox list user control I have created. Then I have created this main layout is the layout which appears. So the way Blazor works basically is this app raiser is the main base of the Blazor application, which internally calls this main layout, which is your the single page framework. So the SPA, when we talk about SPA, Blazor is SPA based or single page application architecture. So this main layout is the base which contains the whole application. It contains the navigation. So if you see here, this main layout has the nav menu, and the other thing like this @ body represents all the components which appear. So when I run this application, right now I'm running the Blazor Wasm, you can see here, and this Blazor Wasm is set as the default project. So you can see here, this is the common UI, and you can see on the title here, it's appearing as Blazor Wasm. The look and feel will be same in both the scenario, whether it is Blazor Wasm, server or PWA, whatever we are using. And the only way to identify that whether this is a server application or a Wasm application is to either check to the title, which is like here I have written Blazor Wasm, or you can see the developer tools to see that what kind of JS file is being called. So when we go into the network and when we refresh this page, you can see here that blazor.webassembly is being called. This is basically Blazor WebAssembly page, and you can see here that counter is there, this counter page is there. This is the checkbox list example. So I can select any checkbox. Let's say I have selected this checkbox. I have, and when I show the checked value, it will show you the checked values. So this is how this common UI is being called, and this common UI is called in the Blazor WebAssembly. Now, let me stop this thing and let me show you Blazor Web. So this is Blazor Web is basically, I'll set this as a startup project. So Blazor Web is our Blazor server application. So again, this Blazor server application is using the same Blazor components library. So I am sharing the whole code base here. So now you will see that here the loading option is not coming because it used to come for Blazor WebAssembly. So here again the same common UI is coming up. It is the same index page, the counter is there, the checkbox list is there, the same functionality, everything is same. But the difference is that the hosting model has changed. This is now running on the server. So when I host this will run on the server. It will require direct internet connection to work, and it is running on the server. We can check this by using developer tools. So when we see in the developer tools network, now when I refresh this, you can see here Blazor server is coming up. So blazor.server.js is coming up. This is your Blazor server application. So this is how we are basically reusing our application, the current like reusing the code which we can use, which we have developed for the application. We are reusing this code in Blazor server as well as Blazor WebAssembly. Now let me show you the desktop application also. Although desktop application, as I said, is a bit tricky. So if I run this thing, this is run using Chromely. So you can see here, this is the like cross-platform desktop application. I know the challenge here is right now it's not implementing the CSS which is there commonly available in my common project. So it is not picking up that CSS. That's why the menu is not appearing like the web application or the WASM application, but the things are working as we are expected. So tomorrow when Chromely people will help me out, I can even declare, or I can even expose this application as a Blazor like Blazor desktop application. So this can be exported as a desktop application, and the best part is that this desktop application is completely cross-platform. The reason I didn't choose to use electron.net or electron is number one, its dependency on Node.js, and the package created by electron.net is very heavy. Like if you see the, let me show you basically the comparison of web window here. So this is the web window, and in the web window blog post, this blog post is by Steve Sanderson, who is creator of like Blazor. He has created this web window also. Unfortunately, I was not able to utilize that web window framework, but web window has, you can see the sizes, memory use and size of the electron application. So a blank electron application takes 134 MB, whereas web window plus Blazor takes just 86 MB. Now let's see our application, which is this Blazor Dex. This is basically Chromely based application. So when we see this application, let me see, open the folder in File Explorer, bin. So this is our x64 debug .NET Core 3.1. So this is our Chromely application. And when we see this application, okay, this is also big as Electron, but Chromely people has said that it is smaller. So I'll have to check with them also. So we'll have to find out. But the thing is that the benefit is that Chromely is right now a bit more supported than web window. That's the reason I have used like Chromely. And again, as I said, that I was not able to implement web window well because there are some challenges with web window also. But again, the main idea is that you can utilize one single UI which you have written. This basically, this Blazor components, this is a Razor class library. So when you create a Razor class library, that is a component library created in .NET Standard. Right now I'm using .NET Standard 2.1, which is the latest .NET Standard, which has support for C# 8 also. So you can utilize all the benefits of C# 8, which is available on .NET Standard. And you can create a common web UI which you can share between web, desktop, as well as WASM application. So that is the main benefit which I wanted to show, that how you can create a multi-platform application using Blazor and associated components like Chromely or web window or electron.net. You can use any of these three and you can create desktop, web, as well as desktop and web application using just Blazor. Okay, so yeah, so this was the demo. Yeah, navigation and routing. I explained about shared UI logic, how I shared the UI between the platforms, that is using one single Razor class library. When we talk about navigation, as I said, that navigation uses your nav link. So if you see here, there is the nav link, and as you can see, Blazor is basically a component based architecture. So just this counter here, this is a component. So this is counter is as a page also, and we can use the counter as a component also, because every Blazor component or every Blazor page is basically a component which can be utilized in any other component or page. Okay, so that's how you can move from one page to another, and you can utilize one page inside another page. So this checkbox list is also a component which can be utilized in other page, and this one counter is a page as well as component which we have utilized at two different places. That is, we have implemented it as a separate page also, and we have utilized it in the index page also. So that's how you can utilize the component based architecture of Blazor. And the navigation works by the using of page, or you can use the nav link, that is this one. You can use the nav link to navigate from one page to another. So this was the demo. So how you can get started with Blazor? So to get started with Blazor, of course, you will require Visual Studio 2019 or Visual Studio Code, whatever you choose. I usually develop on Mac. So I use Visual Studio 2019 for Mac Community Edition for my Blazor development. And you can use Visual Studio 2019 for Windows also. And you can use Visual Studio Code. Rider also supports Blazor development, but I haven't used Rider, so I don't know much about it. You can visit official doc site, that is blazor.net, to use to learn more about Blazor, how the component works, and how you can utilize this thing. Web window is basically, I have given the link. It is available in Steve Sanderson's GitHub profile. Web window, and Chromely is again available as Chromely apps. So it's an organization page, Chromely apps, and it has all the demos. So Chromely is just like your electron.net, where electron.net is dependent on Node.js, or Electron is also dependent on Node.js. So Electron is basically the JavaScript framework, cross-platform JavaScript framework, based on which your Visual Studio Code, your Slack, and other web applications, desktop application are being created. Similarly, electron.net is the port of Electron in .NET, which you can utilize, but it also has the dependency of Node.js, whereas Chromely basically uses the native capability of .NET framework, cross-platform capability of .NET framework, to invoke Chrome and run it. So it uses Chef and Chrome engine to run your cross-platform desktop application. There is this community docs. It's basically a collection of all the community documentation, whatever open source projects, like lessons, chapters, videos, articles, all the collections is in the name of Awesome Blazor. So if you just search Awesome Blazor, you will get these two lists. These two are very popular. This Adrian Torres one is regularly updated. He updates on weekly basis. So you can utilize this one. So that's all from my side. Thank you for attending this session. Any questions? I'm up for questions.
That was great, but I don't think we are taking questions, Ravi, today. No questions being asked today, but we bring you back. There looks like a lot of material there with Blazor, so many new things. So we need to get you back on just like a dedicated show for like hour and a half or two.
Sure. Would love to do that.
Yeah. Once again, thank you so much, Ravi, for being a part of our community here at CSharpCorner.
Thanks,
we're
Mai.
very happy to have you. And it is time to introduce our next guest, Vishwas Lele, the Chief Technology Officer and Microsoft Regional Director.
Hello, Vishwas sir. How are you? Yeah, you mute, I think.
I can hear you.
All right.
Yeah. There you go.
Hey, hi, Mike. Very nice to meet you as well.
Nice to meet you, and welcome to our .NET Virtual Conference. We're very excited to hear what you have to say.
Yeah, and sorry we're running 10-15 minutes late. It just so it's all you. We won't take too much time.
Thank you once again for inviting me, and thank you for that intro. That looks much nicer than the work actually I do. So thank you.
That's all Simon. He's doing a good job.
Yeah. So all the people who are watching this, it's not as nice as the video projected me to be. So, okay, here is, I'm going to get started, Mahesh, if that's okay with you.
Yep.
Of course, take it away.
Please.
And Mahesh, I should just be able to just say share the entire screen, right? Okay, very good. Are you able to see my screen? Just a quick check here. So, Mahesh, I hope you can see my screen, and you can?
Yeah, screen is good. Everything is good.
Screen is good? Okay, very good. Okay, then thank you again. Thank you for having me. I was watching the previous presentation about Blazor, very interesting stuff. So I encourage you to explore the great links that our previous presenter had. I'm here to talk, just take a few minutes to talk about this topic, which I have not presented before. So, I'm sure you've seen many talks about Kubernetes itself, an introduction to Kubernetes and AKS. And, I've done some of those talks myself. And I wanted to present a slightly different take on Kubernetes. So Kubernetes is fundamentally changing how we'll be building applications. It's already doing so. And I thought I will take a step back and talk about a few trends that can help you look at some of the changes that are happening in the landscape and in the Microsoft ecosystem, but also across the other cloud providers here as well. So this is brand new content, and anytime the speaker tells you that this is brand new content, you have to put your seatbelts on, because it's not going to be as polished. It's not been repeated. But the good news is that this is content that others have not seen before. Okay, so before I show you even my agenda slide, I just wanted to motivate the discussion here, okay, and really talk about Kubernetes and containers. And here are some numbers that you probably have seen them, but probably worth going over here. So this is Gartner saying 50% of the enterprises will be running mission critical applications in Kubernetes or in containers, I should say, cloud native manner. Look at some other numbers. 77% of the companies who are choosing an orchestrator are choosing Kubernetes. 50% of the large companies are adopting. So you can see this is a fairly recent survey conducted by Datadog. And you can see Kubernetes is having an impact across IT. And this is not just Microsoft oriented or Azure oriented folks. This is across the board. So you've seen this. Let us switch, and I have to say this, that if you're new to Kubernetes, this presentation is not an introduction to Kubernetes. So if you're new, I might say some things which you may not fully be aware of. So, in that sense, some topics may be 200-300 level. But what I tried to do, I looked at this presentation, I went back and added a few conceptual slides. And remember, I have not even showed you the agenda slide. So this is all still motivation for this talk. Okay, so first and foremost, so what is microservices? In fact, let me go to this slide and just say one other thing here. So when we talk about Kubernetes and containers, it's not just the containers or Kubernetes itself, right? I think of, almost like three things or even more, the confluence of these things coming together, which is really causing this interest in Kubernetes. So, of course, the notion of microservices, which I'll talk about briefly, the notion of containers, and then orchestrator. The confluence of these three things is what is creating all this excitement. So I'm not going to spend too much time on microservices, but I think whatever your definition of microservices, one thing is very clear. As an industry, if we are going to be building these monolithic applications, which have all of these pieces connected together, the chances of success are greatly reduced. And I hope we can all agree that building your applications in smaller pieces gives you a better chance of success. And that's my very raw definition of microservices, right? And you can look at through the slides. There are other benefits, of course, autonomous, scaling independently, technology agnostic. Of course, there are all these benefits. Okay, so here's a picture of a monolithic app, and I provided the source at the bottom. Very good book if you're interested, Microservices Patterns in Java. So here's an example of a monolithic app. And as you can see here, this application has different components. There's a restaurant management, there's order management, but they're all tightly connected. Even though there's a web layer, there's a REST API layer, these pieces are all tightly connected to each other. And as a result, all the challenges that I talked about in the previous slide, where if you make a change in one area, it has a ripple effect on other areas, and all of those things come into play. So here's the complexity of the application. The development can be slow. If you want to make a change in one component, you have to orchestrate that change with all the other subsystems. And then you have, the scaling can be difficult. Why can scaling be difficult, right? The scaling is difficult because the scale characteristics of the restaurant app versus the delivery management may be different, right? One may be memory constrained, the other may be CPU constrained, and just scaling it across the board is not very efficient. So things like that. And then the last thing is the blast radius, right? Something happens in one of the pieces, the blast radius, the impact on the application is great. Okay, so that's the challenge with monolithic apps. And what we are finding increasingly is we are building microservices-based applications that essentially give you better testability, easier to manage. You can independently scale, and I'll show you this in a little bit of detail as we progress through this. Okay, so that's the microservices architecture. And by the way, if you're interested, how would you take that previous application that we looked at, which is right here, which you saw right here, and how can we really redo that in the terms of microservices right here? So here's the order service. Every piece of functionality is implemented as a service in itself. Okay, so we have covered the very basic component of a microservice, but I told you it's the confluence of three things: the microservices piece, the containers, and the orchestrator. So let's shift gears and get into Kubernetes. So what is Kubernetes? Once again, it's an open source project. Why so much excitement behind this? Note here, it is one of the most popular GitHub projects in number of stars it has received in terms of number of contributors. Obviously, a very popular project. And if you're interested in how the name came about, a Greek term for pilot or helmsman. And this is probably, let's spend about 60 seconds or so on this slide. So this is my favorite slide about Kubernetes, and this gives me a good way to explain what Kubernetes is all about. So ultimately, when you're building your applications, before sort of containers and orchestrators came along, we had some sort of a virtualization in place. We would deploy our applications to a server. Now, as you grow the number of servers, it's really hard to individually manage those servers. Why? Because one server may be running application A, B, and C. Server 2 may be running application D, E, and F. But are you fully utilizing this? What if application A goes down because first server has gone down? Who's responsible for moving those applications? Those are common challenges that we face in deploying these applications. So what Kubernetes essentially is doing, this diagram shows you, it takes these two nodes. These are two machines. The green boxes are machines, and make them appear. And of course, because of the space I have, this could be literally hundreds or even thousands of machines where your applications are running. But what Kubernetes is giving you, and you are the user right here, we'll talk about this persona in a second. You're the user here. You are essentially telling Kubernetes to deploy your application, and then Kubernetes is distributing the application across these nodes right here, right? So think about it this way. Kubernetes is taking these collection of hundreds of servers and providing a facade for you as if there was only one server. And then under the covers, it is distributing these applications in a manner. So one of the things that you must have heard of is something called the bin packing, nothing to do with Kubernetes. But why am I bringing this up here? So today, if you go to any cloud provider, and you look at the CPU utilization of the virtual machines that are running in any cloud provider, I guarantee you the number is in low teens or 20%. You're paying for the entire machine, but you're only using 20% of the machine. So where does bin packing come into play? The idea is that can I distribute my applications in a manner that I'm using the capacity in a more efficient manner. So I'm packing my applications in a manner where I'm utilizing this capacity well. So Kubernetes offers you one such thing. All right. And then the other nice aspect of Kubernetes, of course, is that all you have to do is use a consistent API to do everything. And then we will build on this theme later on. So the green boxes are the boxes where your applications are running. The blue box is sort of the control plane. And this is the, we don't have time to get into every box here, but the control manager, let's take this into account. Control managers, for example, are responsible for bin packing that I talked about. This should go to server 1. Oh, by the way, this is a Windows application, and this should go to a node that is running Windows container, so on and so forth. That's what that's what the scheduler is doing for you. And the control manager, of course, is responsible for making sure that all the things that you've asked for are being allowed and being enabled to you. And then finally, all of the configuration, and this is the nicest part, all of the configuration within these machines is being stored in some sort of a configuration database. In this case, happens to be etcd. Think of this as another key value data store. Okay, so we've talked about the blue box, we've talked about the green boxes, and then let's talk about how will people consume your application. Well, they consume your application by coming in from here, right? And you as a user or an IT administrator are deploying your applications from here, but the consumers of your application, whether it is a web application or an API or something like that, they are coming from here. The last thing to explain in this diagram, and see this dotted line here, and then you see this cloud provider network edge. This is the interesting part here, that Kubernetes is built on extensibility mechanisms. What do I mean by that? Well, if you see what Microsoft has done with Azure Kubernetes Service, if you go out and want a load balancer, right? You're building a web application and you want multiple instances of your application running, which are load balanced in some manner. And if you're running in Azure, you want the Azure internal load balancer or an external load balancer. But because of the extensibility architecture, Kubernetes fundamentally goes in and gets you the load balancer. Okay, so that concludes our very, very fast whirlwind tour of Kubernetes. The reason I went into a little bit of detail is I'm going to use these concepts later on in my presentation. But let me summarize what I wanted to communicate, just one or two things in this slide. So first and foremost, making a collection of machines appear as a facade, being able to distribute this application in a highly packaged manner, and then being able to take advantage of cloud native capabilities like load balancer without actually going to, so today on Azure, you'll go to the Azure internal load balancer. On Google, you might have something similar, or on Amazon, you might have something similar. But letting Kubernetes essentially deal with that aspect. So 3 things to take away from this slide. Okay, moving on. Let me shift gears and talk about, so now that you know what is Kubernetes, let's spend maybe a couple of minutes on why Kubernetes. And then I will show you the agenda slide, and then we will get into the heart of the content here. So this slide is designed to communicate the value proposition of why Kubernetes. So first and foremost, and what I'll do is through the slide transitions, we are going to talk through each of these bubbles. So first and foremost, there is a separation of concern. So what do I mean by that? As a developer, and remember the previous diagram, as a developer, you come in and you say, hey, Kubernetes, deploy my application. There's a separation of concern because at that point, the Kubernetes scheduler is going and deploying your application for you, right? Sorry, my Google Assistant turned on. I didn't even say Google. And let me just turn this off before it says anything else. Sorry about that. So one is separation of concerns. So you as a administrator or a developer, you're just saying, hey, deploy my application. But how that application is getting deployed is somebody else's responsibility. And that's what the separation of concern I'm talking about. The next point, the ability to scale your teams. So today, if you look at any data center, you have folks who are running this data center. They have to worry about set of machines. They have to worry about how this application gets deployed. There is some uniqueness about, hey, these servers are these kinds of servers and they need this kind of patching schedule. And I have another set of servers and they need a different way of managing it. So your operations team finds it difficult to scale. With Kubernetes, what's happening is your operators are operating at a cluster level. And in that manner, it is far more consistent for them to manage these applications, so it's able to scale better. Let's talk about self-healing. And all of us who are attending this talk today can appreciate this. Getting a call at 2 a.m. because the application is down, and then having to log in and maybe restarting the web server or something like that. We've all done throughout our careers, right? What Kubernetes tries to do is the self-healing is built into Kubernetes, which means if one of your applications becomes unhealthy, you can set up a rule and Kubernetes will restart that application. The next is declarative configuration, and this is really important. So today, when we set up both the infrastructure in your application, you are doing it in an imperative manner. What do I mean by that? So I will install the operating system. I will install these packages. I will get these NuGet packages on top of that. So I'm layering on top all of my infrastructure software, and then I'm layering on top of that all of my application software. So with the declarative configuration model, rather than additively building your configuration, you're telling Kubernetes, this is my configuration, go make this happen. So I want this load balancer, I want this much memory, and I want 3 copies of my application running because this is a critical application. And oh, by the way, if the load grows on my system, add more copies of my application. All of this is being communicated in a declarative manner, and then Kubernetes is responsible for managing this configuration. So 2 things there. Not only is it responsible for making sure that this configuration is enabled when you start off, but you have to also make sure that this configuration stays the same, right? If one of the applications becomes unhealthy, the number of copies of your application just went from 3 to 2. And then Kubernetes needs to figure out that, hey, you asked for 3, let me go find another instance on one of the cluster machines so that you are back to a level of 3. Okay, the next point, the power of immutability. And this is where the notion of containers come into play. And much like I talked about the infrastructure where you have to assemble it additively, even for the application's sake, being able to create a snapshot, immutable, hermetically sealed image of your application essentially is what a container is all about. And the power of immutability is this, that remember the previous example I gave you where I said that if my replica count goes from 3 to 2, please start a new application. At that point, Kubernetes doesn't have the time to make sure that all of the application binaries and dependencies are all available on that server. All it has to do is get the right image, launch the container based on that image. So the power of immutability is really important. The next thing is the velocity. So we've all come to learn over the last few years, we have come to learn that things like blue-green deployment, which means no downtimes, and you are incrementally adding or updating your application. Things like testing in production, right? So you want to roll out a new version, but you want only 1% of the users go to the new version because you want to figure out if they're getting the right experience. If they are, you can incrementally roll out to a larger percentage of users, all of those things. Ultimately, what we are talking about is time to value. How quickly can we cycle through this and bring functionality to our users? So I'm going to run through that. I've stayed on this slide for maybe maybe one or two extra minutes. So I have to hurry through this a little bit. Efficiency. I'm going to skip through this because I've already talked about that. Remember, I was talking about bin packing, paying for the entire virtual machine when you're only using 20% of it. That does not make sense. We want to be able to create these infrastructure or these services in a high density manner, so that we only pay for the things that we are using. And the last one, which was I did not cover here, in addition to efficiency, of course, is the abstracting the infrastructure. So your infrastructure is completely abstracted from the application, and we'll talk some more about this. Okay, so with all that hard work, and it took about good 10 or 12 minutes to get to the agenda slide, let us now get into the heart of the content, which is, now that you understand Kubernetes, now that you know it has become such a dominant force in application development, how is it changing the applications we build? How is it changing where we deploy applications? How is it going to change how we manage these environments? And those are the kinds of things I talked about. I could have easily added 10 more things to this list. And in fact, till late last night, I was debating which ones to include. So here, I picked up a few of the items right here. So the first is DevOps 2.0. What do I mean by that, right? So we are all become aware of the importance of DevOps over the last several years, and this idea that you should automate everything, infrastructure as code, and CI/CD pipelines, and all the efficiencies that can be had. So we've really gotten a good understanding. Many organizations are using that, but we still have a lot of automation code that we write. So even though we are taking advantage of CI/CD, we are taking advantage of all of these DevOps enhancements, we still have a lot of code to write. And this is where it brings us to the first notion of DevOps 2.0. And let me show you a hand-drawn diagram here that I sketched, because I couldn't find this equivalent diagram that I wanted to use here. And let me get myself a pen here so you can see this a little bit better. Okay, so what do I mean DevOps 2.0? And one reason Kubernetes has become so popular is it's not a technology that is limited to developers alone. It is a technology that is of interest to IT administrators as well. Okay, and that's why. And ultimately, if you think about it, what is DevOps, right? It's bringing the development and the operations aspects of them and gelling them together, right? That's what DevOps is all about. So what Kubernetes allows you to do, essentially, why it appeals to both communities of people, is because as a developer, right, and this is the dev persona right here, as a developer, I can come in here and write my applications as microservices, and those microservices will manifest themselves as pods. And I've not introduced the term pod, you might know already, but think of pod as a container just for the purposes of this discussion. But truly, a pod can be one or more containers, right? But as a developer, I can come in and say, here is my Node application, or here is my PHP application, or a .NET Core application, and I've built this application through a collection of microservices, and I'm going to create these container images to be deployed as pod. I also have a need to run a job on a timely basis. I need some batch functionality. I need some persistent store. So as a developer, I need these constructs. And if my microservices is stateful, then I need a stateful set. And once again, these are Kubernetes terms that you can easily look up. Okay, so how does this relate to DevOps 2.0? It relates to DevOps 2.0 because here is the admin persona. Admins can simply take these objects, a deployment object, a pod, a volume. They can simply, there's a well-defined notion of these objects. What admins can do is take these objects, simply deploy them to the Kubernetes, and what admins are bringing to the table are things like the configurations, things like if you're going to ask for a storage, they get to define, are you going to get premium storage or are you going to get a basic storage? They get to define that. Or if you're bringing a secret, oh, that gets stored in a secret or a key vault or something like that. Or you're using the identity, well, the identity comes from this admin persona. So much better workflow in terms of the dev and admin incorporation, right? Collaboration. Okay. So the next thing I want to talk about is multi-cloud. So we've already talked about DevOps, how Kubernetes is enabling a much better collaboration between devs and ops. Let's talk about multi-cloud now. So let me go to this next slide here. So multi-cloud. So Kubernetes, one of the amazing things that has happened is there's something called the Kubernetes conformance tests. So these vendors that you see here, Google, Amazon, Azure, whoever else, they all have to make sure that their offering of Kubernetes is conformant to the standard set of tests that CNCF or the Cloud Native Computing Foundation has set out, which means you have the same constructs available across different clouds. And let me show you a quick example of that. So I'm going to I have some demos here, and I'm going to, and before I show you the demo, let's just go to the browser here for a second. And let me go over to, so this is the Google Cloud right here. And just this morning, before the presentation, I spun up a cluster in the Google Cloud called Cluster 1 right here. Okay. So what I'm going to do here, I'm in Visual Studio Code. And if you are familiar with this already, Visual Studio Code has a very nice extension that allows you to talk to the various clusters. Right now, it looks like I'm talking to the Azure cluster, AKS cluster. Let me go and change this to make sure I talk to the Google cluster or GKE cluster, and let's see. And I'm going to set the namespace as cross-cloud, okay? And once again, my goal is not to teach you syntax. This is more conceptual. So let's go to M20. This is the code that I have right here. And now that we are connected to, so let me, so just want to make sure I delete this beforehand. So delete this pod right here. And this might take a second or two to get deleted, and I'll tell you why it is taking that extra time. So let's, in the meantime, take a look at the code right here. So the exact same code works across AKS and the Google Cloud, and there's only one minor difference. So first and foremost, here is my pod definition. So right here, I'm creating an application. That application is comprised of a container right here, and my code is in my Docker Hub. You know all this already. And remember, we were talking about better density deployment. So I get to tell them how much of CPU do I need, how much memory I need. So that's how the schedulers get doing things here. The exact same code works on Azure as well. The only difference is the following. Let's just go here, right here. So the only difference is that in terms of the storage class right here, in this case, I'm going to a persistence disk in Google. In case of Azure, I'm going to an Azure disk. And in case of Amazon, I'm going to an EBS volume. That's the only difference. But the code that as a developer I wrote is essentially the same. So this code, so whether it is getting published from my Docker Hub, all of the other characteristics are the same. The only difference here is that I'm telling Kubernetes, hey, when you deploy my application, I need some persistent storage. And by the way, I want to make a claim about the persistent storage right here. And if you look at that claim right here, in this case, I'm just suggesting that I want 1 gig of storage, and I want to read write storage. And then that's all I'm defining in terms of persistent storage. And on the Google Cloud, that persistent storage gets mapped out to GCE and Azure Disk and so on and so forth, right? So we might even not want to, just for the sake of completeness, I'll just run this code here. Let's just run it against the Google Cloud. And sorry, I need to change the directory to CM20. Let's try it this time. And pod got created at this point. At this point, it is getting ready to start. If we keep looking at it and come back in a few seconds, this pod will get started. The reason it is taking a couple of extra seconds is we are asking it to dynamically go find a persistent disk, a GCE persistence disk, and that's why it's taking a few seconds. Okay, so let's go back to the slides right here, and I'm doing in terms of time right here. Okay, so I have about 10 more minutes left. So we have talked about multi-cloud already. Let's talk about the common control plane. Okay, so what do I mean by that? So right here, so now you have Kubernetes clusters. I showed you a cluster running in the Google Cloud. I obviously have clusters running in Azure. I could have a cluster running on my edge location. If you're paying attention to the Ignite announcements 2 weeks back, AKS now supported on Azure Stack Hub. So you could have Kubernetes instances just about anywhere, right? Private cloud, public cloud, on-premises, edge location. So how do you go about managing these clusters in this manner? And an important pattern that is emerging is something called the Azure Arc for Kubernetes. So the idea is, and what I've done here very quickly to show you this demo here, let's go back to the browser. And I'm going to go to the Azure portal right here. And if I go to all my Kubernetes clusters, and let's just zoom into this. So right here, you see this cluster. Turns out that this is the Google cluster, which is appearing inside the Azure portal. So if I go in here, you can see that this is a resource group within Azure. But what Azure Arc is doing for us is it is going out and reaching to the Google Kubernetes cluster and providing us a control plane so that we can manage. And let me just show you an example of what I mean by managing it. So if I come here and look into policies, so notice here, I'm running inside Azure portal, and I can come in and look at the policies that are being applied directly against the Google cluster right here. Okay, so going back to the slides. So we have talked about DevOps 2.0. We've talked about multi-cloud development. So imagine writing your applications that can be deployed across the cloud, and then imagine being able to have a common control plane across the different environments where Kubernetes is installed. Let's keep going. 2 more things, and I have about 7 or 8 minutes left. So I want to spend about 3-4 minutes on each of these topics right here. So portable distributed application patterns. So you've probably heard of a very interesting project that has come out of Microsoft called Dapper. And I want to talk about Dapper. Dapper, keep in mind, works in 2 modes. It can work in Kubernetes or it can work in a standalone mode. For the purposes of the discussion here today, I'm going to focus specifically about Dapper running inside Kubernetes and what it brings to the table. So let me bring up this diagram right here. So what is Dapper? So Dapper is a runtime. So if you're building a distributed application, turns out that you need things like state management, you need things like distributed tracing, you might need the actor model, you might need some service-to-service invocation, you might need some message and subscribe patterns. These are all common patterns that you need when you're building a distributed application, right? So we already talked about how Kubernetes makes things available across multiple clouds. So what is the purpose of having Dapper, right? The purpose of having Dapper is that it it is a layer that sits on top of Kubernetes. And once again, I'm talking only about Kubernetes instance. It does not need to sit on top of Kubernetes. Dapper provides you these patterns right here. It provides you these patterns that make your application workable across multiple different environments. So rather than taking a direct dependency on, let's say, Redis, if you wanted to do caching, you are taking a dependence on Dapper, and then Dapper can, through some configuration setting, map to Redis or to something else without you having to change your code. That, in a nutshell, is what Dapper is offering to you. So not only are all of your Kubernetes objects like pods and services portable across the cloud, all of the application constructs like caching, actors, pub/sub, they also become portable across the cloud and portable across languages and portable across framework types. Okay, so that's what Dapper gives you. And I think I have one other slide. I don't think I have time to run through this demo right here, which is demo number 22, if I remember correctly. But I will, so once again, right here, Dapper is just like a Kubernetes object right here. The only difference here, and you will see if I go further down, line 32 to line 35, I have Dapper enabled this application. And what that means is, if Dapper is deployed on my Kubernetes environment, as soon as my application gets deployed, the Dapper components will kick in automatically. And only dependence I'm taking is I'm talking to Dapper, and then Dapper in turn is essentially talking to Redis or whatever state provider that you have configured. And this code is available. I think I have this is a sample code right here. You can see this is the Dapper Hello Kubernetes code right here. And we don't have time to get into a lot of details here, but essentially information about Dapper is passed into this container, and that's all it needs to do. There is no hard reference to some Redis SDK that will cause you to recompile your application. Okay, so once again, you now have an ability to write portable applications because of the Kubernetes plumbing. But on top of that, you now have an ability to write an application that can bring any framework on any platform, essentially. So that's Dapper. Let's go back to the slides. And the last thing I want to talk about, which is extensibility. And Kubernetes offers something called the custom resource definitions. So imagine all of the things that we talked about, the ability of scheduler, the ability to write cron jobs. So Kubernetes provides you really a rich ecosystem of capabilities. Wouldn't it be nice if you could extend that underlying fabric to build your own applications? So I just wanted to show you an example of that. And I have to remember where my demo number is. So that's 19. And all of the source code is available to you. I will show a link. It's if you go to Lele GitHub, you'll be able to find it. But let me show you an example of an application. So let's make sure the first thing we want to do is we want to change to this directory. The other thing I want to do is I want to change my cluster from Google to an AKS cluster, send that as the AKS cluster right here. Let's just go back to a custom resource definition example. So right here. So there's a lot going on here, but the best way to explain, let's see if I have a better slide before this code will make sense. I think I do have a slide here. So right here, you can see these are all objects we've talked about. Stateful set, pod, persistent volume. These are all Kubernetes concepts. What if you wanted to introduce your own concept? And here is an example right here. So basically, I write my own controller. I can now introduce a type of object in this case, MySQL. So you're extending Kubernetes to take advantage of the Kubernetes capabilities to build a custom application. Let's go back to the code now. Okay, so imagine, and here's the motivation for this code. Imagine that you wanted to write a resource type where you wanted to build a web application, and you wanted to say that this web application will serve all content from some GitHub repository. Okay, so everybody with me so far? Essentially, you're trying to build a web application, and you want to say that all of the content that is served by this web application is stored in a GitHub repository. Now, what you could do is you could write your code in Node or whatever language. You could write, essentially create a container, create a pod, create a service, do all of those things yourself. But wouldn't it be great if you could create a new object of type website right here? Okay, and so this is, and see the name here, this is my own type. This is not a type provided by Kubernetes. This is my own type called website. And I'm providing the specification of the GitHub repository from where my content has to be looked up. And this example is coming from a book called Kubernetes in Action, which I think is one of the best books on Kubernetes. So if you're interested, please take a look. I wanted to give a shout out to the author for this book here as well. So imagine I can write my own object in this manner. And then in terms of, so once I've defined my own object, I can come in and then I can also define my website. And ultimately, let's see which namespace is this running in. So it's running in the default namespace. I just want to make sure that I've set the default namespace. Yeah, so the star here, so it is in the default namespace. So right here, if I can write commands like this, kubectl get websites, because it knows that websites is an object right here, I can do things like, hey, Kubernetes, give me a website. Okay, so that is 227, and I think I should stop right here. Hopefully, I've given you some things to think about of how Kubernetes is changing the way we build, deploy, and monitor the applications that we are building.
Thank you, Vishwas. That was a wonderful presentation.
Yeah, a lot of learning in 40 minutes. We need probably a few hours for this.
Yeah.
Yeah,
it's been a common theme today.
Is these 40-minute sessions, but they're good from perspective that you're able to hear a lot of speakers and a lot of topics. And I will share out the link to all of the code base so that people can find a few hours on a Sunday morning and try those examples themselves and explore it on their own time.
All right. Thank you. I know you're running late for your meeting. Thanks for joining us, Vishwas.
Thank you. Thank you, Mahesh. Thank you, Mai.
Yeah, thank you. Thank you for being a part of our community here at CSharpCorner. And now it is time to welcome our next guest, Drew Hartley, a software engineer leader.
Hey, Drew, welcome to the .NET conference.
Hi, it's great to be here. Thanks for having me.
We're so excited to hear what you have to say to us and to listen to your presentation. And since we are running a little short on time, we will let you get started right away.
Okay, sounds good. Thanks a lot.
Well, looks like, yeah. Go ahead.
Vishwas is back. Vishwas is my boss. He's just keeping an eye on me.
I see.
All right. Yep, there we go. Let's see the slides. Okay, cool. Thank you so much for having me at the conference. Thanks for spending some time with me, everybody that's out there. I'm really honored and excited to be here. I feel a little bit like the odd man out watching the sessions this morning. A lot of really great technical stuff. But I'm excited because I get to come talk to you about leadership concepts and how to go from a developer specifically into a team leader type role. So we're going to talk about that. Everyone's in a different place in their career. So, I'm going to speak sort of in big terms, but I think there's going to be something applicable for you wherever you are. Maybe you want to be a leader, but you're in a developer role and you don't know how, and this is going to be great for you. Maybe you're not even sure about the leadership role. Well, I think this will be really valuable for you as well. And maybe you're like, no, not for me, but you're still on the session, which would be cool. I hope you'll listen, and I hope you can take some things away as well. All right, let's real quick talk about me. I'm not that important in the grand scheme of this talk, but I am a family man. I love sports, every kind, and I love being outdoors. I was a developer early in my career, but I've really turned into a senior software engineering leader. Like the intro said, I'm an account executive at AIS. Vishwas, who was just talking, is my boss. I'm super grateful to be working with him and the awesome team at AIS. But I also do blogging and leadership coaching, mentoring, speaking, training at my website, leadasaservice.com. So that's just real quick about me. Enough about me. Let's talk about a few rules of the show and our time together. So one, I want this to be for you, and I want it to be as valuable as it can be for all those out there that are watching. So send your comments. Feel free to send them at any point in time. You can interrupt. I'm going to keep my eye on those as best as I can, because I want to be able to address those. I like these sessions. I think it's really valuable when there's an actual audience we can engage personally, and so that's a little different in this session. But you can still send comments, and we can have a conversation. And so it can be on anything that we talk about. I can jump backwards. I want this to be valuable for you in our time together. All right, I have 3 simple goals with our time together. It's one, I want to increase interest in being a leader and moving from that developer role into a team leader. I want you to see how awesome it is, the super exciting opportunity it can be, the impact you can have. But I also want it to be practical. I want you to be able to take away some practical steps that can help you along your leadership journey, no matter where you're coming from. And I want to give you some practical tips so that when you do get the leadership opportunities, you can actually lead well. So I have 40 minutes, 35 minutes maybe now to go through this content, and it can feel like a lot. So I want to make sure if I only have your attention for 1 more minute, you can at least get the spoiler of the most important things that I want you to hear. One, I find that a lot of developers who are interested in team leadership, they have a lot of fears, and that can block them from moving forward. So number one, don't let fear stop you for pursuing a leadership position or anything for that matter. 2, you can do it. It starts with the belief in yourself. 3, leadership is really awesome, and it's also really important. It's a really noble role that has a really big importance and purpose behind it. Your motivation is the number 1 requirement. It all starts there, whether you've had training or experience or you've had none of it. You've got to start with this desire and motivation to move into a leadership position, and everything else can be built on top of that. 5, the place to start is where you are right now. You've got to start being a leader from where you are. 6, grow your leadership skills by learning. And 7, you got to take action and be proactive and take initiative and go find opportunities. Okay, so that's the quick intro. We're gonna jump in now to the content. I'm gonna make sure I can see comments over here. So please feel free to drop those in the comments box if you have them. Okay, so you're a developer. You love being a developer. You love spending hours in front of your computer coding. And you get special satisfaction when you deliver beautiful code that's working perfectly. Life is good. You're happy, you're engaged, you're productive, you're in control. You're really content with what you're doing. You're excited about it. And then one day something crazy happens. You think about the future and you think to yourself, is there something different I want to do? Is there more to my career? And you have this thought, would you want to be a leader? And then all of a sudden, these fears pop into your head and these concerns pop up. You're like, change? Why? I've got a really good thing. Why would I want to change? Besides, what if I don't like it? What if I lose my technical skills? What if it's not the right path for me? What if fill in the blank? And you know what your natural response is, which is totally natural, is to run, right? Run, like one of my favorite movies right here. It's coming from this fear of change. Or maybe you've looked at leaders around you, or at Gilbert, Office Space, The Office, other shows on TV, right? The bad leaders are this sort of comical and unappealing thing in sessions. And maybe you've even seen some around you wherever you work. And so you're like, well, the leadership role doesn't look exciting to me. That can deter you. Or you're like, wait a second, look what leaders have to deal with. They've got to deal with people. People are messy. You got politics. That's not fun. More meetings. You've got to deal with HR stuff, planning budgets, blah, 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 blah. The list goes on, right? And so there's this response where you're like, well, that doesn't look fun. And so you've got this fear that the leadership position won't be fun. We're like, whoa, wait, I've seen leaders, that looks hard. They've got to deal with these different things or make big decisions. It looks like it can be very frustrating and complicated, stressful, scary, intimidating. All these things, you're like, maybe I don't know about this idea. It looks way too hard. That's what I call the fear of hard work. Or you're like, wait a second, you know what? Like, I'm not qualified. I haven't been a leader before. I don't have experience. I don't have this knowledge, or I didn't get a degree or my MBA or fill in the blank. Or you think, I'm not even the best developer on my team. Why could I be the leader of my team? Or you're like, I'm not tenured enough. I'm not the right age. I'm not already on a list, or I didn't go through the program. You think to yourself, I'm not going to meet those requirements. So you have this fear of being unqualified. Or then you're like, what if I'm not good at it? Right? I might fail. Or people might judge me if I'm in that position. Or they might think I am pretending to be something I'm not, or I'm not an expert, or I have weaknesses, or I don't know blank. Right? And so these are fears of failure. So I just covered 6. I'm going to quickly look at the comments real fast just to see. Are there other common fears or concerns that you or people you know have? I'd love to see those in the comments. If you could type those in, and we'll come right back to them in a minute. We'll cover a couple things real fast, but I'd love to hear what maybe some of those other common concerns or fears would be that really hold people back. And they may or may not be true, so post any that you can think of. All right, so my response, I hear those six comments, and I'm like, whoa, yikes. After all those thoughts, you're like, you know what? I'm good. I think I'm good being a developer. I know what I'm doing. I'm successful, and so you just stay right there.
So, Drew, you done with your tips, right?
For the fears, yes.
Yeah, okay, whenever you're ready, just let me know. I'll ask you live questions here when you're ready.
All right, give me just, go ahead. Yeah, what do you got?
No, finish what your slides are. So I want to just, when you have time, then I'll just ask live questions.
Okay. Well,
that makes sense.
Yeah. Let me do this. Yeah, go ahead. Are they about the fears? About fears or concerns on taking this step?
No, this is just general discussion, based on my experience, and some people may have those questions.
Yeah. Fire it away, and I'll answer it, or if I feel like something's coming up, I'll address it at that point. What's up?
All right, maybe I will just post in the comment. I don't want to take away your time, so you go ahead and continue.
Okay. All right, I'll watch the comments then. Okay, so I hear all those concerns, all those fears, and my initial response is like, whoa. I'm like this guy right here. Like, slow down. Like, those are all valid things, but they're fears. And what fear does, right? Fear can sabotage you. They put walls in front of you. They become blockers that you can't get past, and they make you freeze. But it could very well be preventing you from going somewhere that could be really amazing, that you can, where you could really truly help others. You could do something really important, and you could love it, right? Maybe that's the job for you. You don't know it yet, and you're not going to know unless you push back these fears. So let's just focus on maybe what the opposite of those fears, or maybe the truth of those fears, to try to dispel some fiction and fact, because fear is normal, but when we have it, we got to address it. We got to talk through it. So one, the fear of change is a natural response, but change brings growth, it brings adventure, it brings opportunity. It's not going to kill us. And if you go through it and you find that the position's not for you, you can always go back. You have the fear of the leadership role. You don't want to be like the boss on the office or office space or Dilbert. But leadership at its core is good and it's valuable and it's important, even if you've seen people represented in a really poor way. Leading a team is fun. It's not the opposite. It's not fun. It is fun. It's exciting. It's rewarding. You get to be part of something. You're in a role that is more than yourself, which is a really exciting place to be. And yes, I'm not going to say leadership isn't hard, but I think being a developer is hard. I think there's lots of roles that are hard, but it is worth it because what leadership is about and the impact you can have. What I know is if you really want to be a leader, then you can do it, which goes to the next one. You have this fear of being unqualified, that you don't have the resume, etc. And it's not to say that there aren't specific requirements for jobs, and it's not to say you may not have to go do whatever, get a degree, take a class, get experience doing something else first. But it's all got to start with a sense of motivation. Right? This is, you may not have the opportunity to become a leader tomorrow, but if you have that motivation and that drive, that you're really committed to it, there isn't any qualification in front of you that you can't get past. And that fear of failure, which is perfectly natural. None of us want to fail, but we've got to look at failure as a step in the path to success and a step in the path of learning. So failure, we don't want failure to be feared. We want it to be a learning opportunity. But what should be feared is regret. And you don't want to look back and be like, man, in hindsight, I wish I would have pursued that leadership path, even though I was scared or fearful or worried. You don't want that regret. That's something that can eat away at you. Mahesh, I don't see a comment yet, so feel free to drop that in there once you're ready, or jump back in, either way. All right, so I've tried to dispel some of those fears, and let me just say, the fears hold you back, but also think about where you're potentially going, and think about what that leadership role is all about. I'm a huge believer that leadership is super important, super awesome. And we need anybody capable of being a great leader to move into it. So one, it is important. As a leader, you have a direct impact on work. Obviously, you impact careers and the path that people take. You impact teams and the success that they have. You impact results in the team achieving wins. And we spend a lot of time at work. Work's a big part of our life. So you're directly impacting people's lives, right? If you think about really bad bosses, they can have a really negative effect on people. They can create stress, and they can kill morale, and they can lead to turnover and dissatisfaction. And so great leaders are really needed, and they're in high demand. And if you can, doing great leadership creates environments where teams and people flourish and thrive. And that's a really important thing that we want to create inside of our work environments. Okay, so, and then it's awesome. You get to have a greater purpose, you make a difference, and you gain from it too. You gain growth that you would not have gotten otherwise, which is super valuable. There's an excitement that comes with being in a position of leadership. And what I think is really cool, it's almost like a family, is there's an aspect of joy and pride that comes from seeing your team members do things or your team achieve things that otherwise they would not have done it. And there's an aspect of love and feelings that it's much like a family when you have a great team. Andy Stanley is a leader that I follow a lot. And he says, if you devote yourself to more than yourself, you'll ultimately have more than yourself to show for yourself. And we get meaning by moving beyond ourselves. And I think there's an aspect you can do that as a developer for sure. But that is innate inside the leadership opportunity, because you move into a role that is about more than just yourself, which I think is a really exciting thing. And it gives a sense of meaning and purpose that is unlike any other, I believe. All right, so what I want to say to you is don't let fear stop you. If you don't try, you'll never know. And a quote that has been an encouragement to me for a long time is something that I came across a while ago. Our deepest regrets will be the risks not taken. Over the short term, we tend to regret our actions, but over the long term, we tend to regret inaction. Our greatest experiences will often double as the scariest. These will be the best stories of your life. And I think that's just a great thing, right? Our deepest regrets will be the risks not taken. So if you're thinking about moving into a leadership position, I really want to encourage you to give it a try. So wow, all right, hopefully that was convincing. And let's say that you already were convinced, or maybe that convinced you, and you're like, I want to try, but I don't know where to start. That is a great question, Mahesh. As a developer, what is the first leadership action you take? What your team members, if your team members don't support their boss, and it's a great lead in to where we're about to go. So I'll address it. And others out there, please drop questions, post them in the comments. I really want to answer those if they are out there. Don't be fearful of posting a comment. Okay, so now we're going to talk about that transition from developer to team leader. And there's 5 areas I would like to cover. So 1 is adopt a belief mindset. 2, lead from where you are. 3, grow your skills. 4, find opportunities. And 5, lead well. All right, first one, adopt a belief mindset. It all starts with believing in yourself. My book, my son has a book that we're reading often these days. And one of the pages says, believe in yourself before anyone else can believe in you. And so that's where it's got to start. You've got to believe that you can be a leader. You got to know that you can do it. I promise you can do it. You will figure it out if you want it hard, bad enough, and you believe in yourself. And so you've got to stay motivated. You've got to commit to it, and you've got to persist. There may be ups and downs, there may be discouragement. I hope it's really easy for you, but maybe it's not easy. Maybe it's going to take you a little while. Maybe you do have to take some classes. Maybe there's some hard work in front of you to be qualified. But if you will commit and you can persist, and I promise you can do it. The second one is to lead where you are right now. So this kind of goes to Mahesh's comment about the first steps that you take. So first step was believe, but the second step is to start leading where you are now. Right now, you may not be in a leadership position, but that doesn't matter. Being a leader starts before having a leadership position. I want to say that again. Being a leader starts before having a leadership position. If you want to be considered a leader, then it actually doesn't matter your position. We'll step through these 4 steps and you'll see what I'm talking about. I'm a firm believer that leadership at its core is influence. It is definitely not title. I'm sure you can think of, hopefully you haven't seen too much of this, but a bad leader, right? Nobody wants to follow a bad leader. And I would argue they're probably not even a leader. They might be in a leadership position, but leaders have influence. People listen, people open themselves up. People allow that leader to speak into their life and direct where they go. And so leadership is influence, nothing more, nothing less. And so to have influence, you need trusted relationships that people will allow you in to speak into their lives. And if you do that, you have willing followers, right? A leader is someone that has willing followers behind them that are going with them somewhere, not people who are forced to go with them. And so you do this right now. You do it right where you are, in whatever position you're in. And we'll talk about how to start doing that next. So you've got to change your viewpoint. You may already be doing this, but if you're not, you've got to look up from just your work. You've got to elevate your eyes from your desk and your keyboard and your screen to what everybody else is doing. You've got to look at the whole team, and you've got to not even just look at what people are doing right now, what the team's doing now, but where's the team going? Where are people wanting to go? And you look at that with a team perspective. This may be a new perspective for you, and if it is, you have to be looking with interest and intentionality around you to understand sort of what's going on in the environment, which leads us to the next step, which is about observing and thinking critically. So now you've got your eyes up, you're looking around, and you've got to observe. So you got to take in things first. I love the quote, seek first to understand, then be understood. And so I think one of those steps is to observe and understand what's going on. So look at your teammates. What are they doing? Look holistically. What are the processes and the systems and the tools and the technology in your team that are using that matter in the work that your team is doing? And then observe the sort of the bigger picture of what's going on. What's the mission and vision of your team? What are the plans? What are the goals? Where's the team trying to go? And so you've got to start observing, maybe asking questions to be able to observe that. you've got to take it in, you've got to start thinking. So you got to think about what you're seeing. You've got to think bigger to say, hey, what are ideas that you have on how the overall team can get better? Where are there opportunities to improve? And you've got to think longer term, and not just about the immediate future, but be thinking about how everything fits together going forward. Once you've done that, again, so just to reiterate, so you're committed to leading where you are. You've changed your viewpoint if you hadn't already, and you're looking around. You observe what's going on, and you're thinking critically about that. And then the step is to engage. And this is where you start acting like a leader in the place that you are, right? And so you got to start doing something. You've got to care. You've got to show that you care. You've got to take ownership. You've got to help somebody. You start getting yourself involved with things that aren't directly related only to what you're working on. And you're showing that mentality of a leader outside of just yourself. Okay, so that quick summary, we went through those 4 steps. Lead from where you are, super important part of this transition. All right, so we've been talking about the 5 areas of focus. Let's just reiterate. First was adopt the belief mindset. Second was lead from where you are. Third is grow your skills. So there is an aspect of growing your leadership skills. If you haven't had a lot of experience, I believe leaders are learners. It's something that I've heard for a long time that I like to believe in. And there's a continual pursuit of understanding the leadership craft and how they do it well. And so you want this intellectual curiosity that propels you towards that education and learning. And there are so many high quality materials out there that are free or not very expensive to help you in that. So there are lots of books, and you can certainly find, do a search and find what the latest and greatest are. You can listen to podcasts. There are a lot of good leadership podcasts that are out there. There's a lot of YouTube videos with leadership and leadership experts that are teaching leadership tactics. And you can take classes, and you obviously don't have to go back to school for those. You can take them on platforms that are available. And so you want to be, you don't need to do all of them at any one time, but I do encourage you to always have one that you are doing that is actively speaking into you and your methods and practices and mindset. And then the next 3 I have on here: study leaders, interview leaders, and find mentors are kind of similar. And who are great leaders that are around you, and observe them and watch them. I've always liked to say, when I'm around great leaders or learning in a leadership context, it's like going through a buffet. And what you get to do is you see all these qualities of what works and what doesn't, and you go through that buffet and you pick out what is going to be great for you and your personality and your style, and you leave what's not, and you leave what's not good, and you use that to sort of craft your style. And so you look around and you see what leaders are doing well and you observe them. But then go another step and actually interview those leaders. I have found in sort of my experience and sort of my mentality is that leaders love to give back. They love to help, generally, if they have time. And so I found people to be very warm and open to the idea of talking to somebody about leadership, becoming a leader, working through a certain situation. If that goes really well and you have a meeting with somebody, take stock and say, is there more value that you think you could get? And ask them if they'd be okay setting up another meeting. And then if that goes well again, and you think there would be value in having a continual relationship and sort of a mentor capacity, ask them if you could make that recurring and something that can happen every so often based off whatever fits their schedule. Maybe that's monthly or quarterly. You can work that out. But you want mentors and people who have gone through the process and can help you and speak into your process and answer your questions. And I think one of the main tips, though, about these relationships is you have to take responsibility for that relationship. You can't just show up to a meeting and be like, okay, what should we talk about today? You have to come with an agenda and thoughts to say, hey, I would like to talk about X, Y, Z. What I found, again, is that leaders enjoy giving back in this way. Because most likely somebody did that for them. So they're paying it forward. And so people are very open to it. But if they're going to do it, they want to feel like it is a valuable use of time. So they want you to be prepared going into it. So I think mentors are really, really important part of this process. Okay, so this next step is about finding leadership opportunities. And the biggest thing I want you to take away here is the need to take initiative and go make it happen. Just because somebody hasn't come to you and said, hey, I would like for you to do leadership position X or this task of coordination or whatever it may be, doesn't mean that you aren't capable, and it doesn't mean that there's not a position or an opportunity for you, but you have to take some initiative to go do it. So don't wait, ask, volunteer, talk to your leader and say, hey, what could I do? I'm interested in pursuing this or trying this. Are there things that I can take on? And this may take putting yourself out there, but you got to be brave, get past that fear, and put yourself there so you can try new things. And it's okay to start small. Maybe you want to start small, and maybe that's the best opportunity. That's fine. But after each opportunity, find another opportunity and try to make each next opportunity bigger or different to help you grow the trust as a leader and the experience as a leader. And one area that I don't think it can be forgotten in this sort of space is when you're trying to grow into a leader, there are opportunities outside work where you can be a leader as well. So there are organizations that need leaders, community organizations, nonprofits that may need development work, right? As developers, we have an ability to potentially offer our skills to community organizations and nonprofits that need it. And that's a great leadership opportunity as well. So these are some ideas. I wanted to try to make it a little bit more practical or specific to just give you some ideas on maybe where you could start. I'm not going to read through all these. You can read them on the screen. But the core idea is to go find something to ask about doing something. You will likely have to take something else on to do this, but there are lots of ways that you can start doing it. And maybe my hope is that some of these ways feel more natural and helpful and doable for you. I like that last one. Ask your leader what they need help with. Maybe they have something on their plate that they could delegate to you, or you guys could work on together. That would be a help to them and also give you an opportunity to, in some degree, step into that role. Okay, Mahesh. So those are sort of, we've gone through 4 of my 5 steps, and we'll get to the 5th one here in a second. So that is answering your question of the first leadership action you would take. That I would suggest. There's sort of the 4 steps in that process. But you also asked what if your team members don't support you being their boss? And I think that can be tricky. And in just a second, we're going to talk a little bit about what leadership is. And the core of leadership is not telling somebody what to do. The core of leadership is a service that you provide to others to aid them in being greater and achieving outcomes and growing. And so, where I would start from that question is if you have teammates that are supporting you, you just start by trying to figure out how you can help them and serve them. People are going to be less likely to trust you and be behind you when it feels like you are the quote unquote boss. But if you're the leader that is helping the team do great things and is there to help the people as part of the team, I find a lot of the hesitancy or lack of support will eventually go away. That's sort of the simple answer. Obviously, dynamics can be different and it can be tough for different reasons. But that's where I'd start, and we'll talk about that here in just a second. Okay, so we've gone through the first 4, and we're going to head over to the 5th one, which is lead well. So let's say you're now in a leadership position. We'll say it's an official leadership position, but it could be one of those other tasks that we talked about to help you sort of step into a leadership position. So I'm going to cover three topics on how you can lead well when you're in that position. Okay, so what is leadership? So this is a little bit of what I was just talking about from Mahesh's question. I like what Simon Sinek says. He's a leadership expert, author, speaker. And he says, leadership is not a position to be attained. Leadership is a service to be given. Again, it's that posture of saying, hey, I'm in this leadership position for the sake of my team members and the sake of the team. I like to say leadership is the art of releasing greatness in others and other people. And so it's others focused. Again, it's about you being in the position, but making it about your team. I find that there's a lot of tension when you have leaders that take over when it feels like it's all about the leader and the team members are supporting the leader. I think it's really important to flip that on its head. And it's team oriented, right? Your goal as a leader is to build a team that is greater than the sum of its parts. And when you can create a really rich, healthy, trusted team environment, the team can then accomplish really awesome, amazing things. And I think leadership is a huge honor. Like I said, leaders impact people's lives. And so that is a really a big thing. And so it's an honor when you're in a leadership position. You're being entrusted with people's lives, and leaders need to respond as if that is the case. And it's worthy cause. One of the goals inside of a team environment is to create an environment where people flourish and thrive. And if you think about flourishing and thriving, those aren't like, hey, they made it through the day, hey, they got the work done. Right? We want to create environments where people are actually becoming the best versions of themselves. They're growing. The team is doing great work. The team is getting better. And so that is sort of how I look at leadership as a whole: service, others focused, team oriented, and it's something that's an honor and a worthy cause. And again, just to Mahesh's question, I think if that is your posture and that's how you're looking at this, you are able to work through a lot of the concerns of people feeling like they don't want you to be their boss, for instance. Now, that was sort of lofty. Now I want to step into something that's a little bit more practical. This transition from developer to team leader does have some sort of tricky hurdles or mental hurdles, I think, to work through and to learn how to do. So I want to spend a few minutes talking about those. So first, learn to delegate and empower. And this can be really tricky. A lot of people that become a team leader were a very high performer as a developer. And so your natural reaction can be, oh, well, I can do that faster, or I will just take care of it, or this is a problem that needs to get fixed now, I'll just do it. And what I wanted to say to you is that you've got to be patient, right? You can to fight that urge to just jump in. Your team will grow and get better when they get to do the work, not when you get to save them in those environments. When you do get involved, though, teach. Make that your primary focus. There's something I heard a long time ago about how to teach delegation. And it goes, first step is I do it as the leader. So I do it. You don't have anything to do with it. And then I do it, you watch. And I teach so you can learn. The next one is we do it together. Fourth step is you do it, I watch. So you take the work on, but I get to be around it to make sure it's done well. And the fifth step is you do it, and I'm not involved as a leader. And I think that's a good sort of model to think through delegation and empowerment, and how, as a new leader, you're thinking about how to not do, but actually teach so others can do. And I think it's really important too, because as a leader, you're taking on new responsibilities and tasks, and you have to be able to focus your time on those things. Those are important, and things that only you can do. If you don't do them, nobody else can. But if there's development tasks that can be done by somebody else, you want to empower them to do that. All right, next is you don't need to know all the answers. Let me say that again. You don't need to know all the answers. I think that can be tricky, again, as potentially a higher performer moving into a team leader position. You may have always had the answers, and you may feel this pressure to know the answers because you're the leader. That is not the case. Your job is to, with your team, figure out the answers. It is okay to say, I don't know. Following the I don't know is the let's figure it out together. You don't even need to be the best. You don't need to be the best developer to be a leader. You don't need to be the best XYZ to be a leader. So I just want to free you of that, because I find that can be this sort of tricky place that new leaders can be in. Next, be humble. People want to work for people that are humble. My favorite definition of humility is not thinking less of yourself, it is thinking of yourself less. And so in this leadership position, you want it to be about other people, not about yourself. And that makes it okay for you to admit mistakes. It makes it okay to ask for feedback. And one of the things I was taught a long while back was a leader's job is to take blame and give praise. That can be tough. To when the team fails or something inside the team doesn't go right, to say, hey, that's on me as the leader. I'm sorry. I will take that. We will get better. And then when things go well, you pass that praise right on to your team members. Next is be yourself, right? Be your authentic self. You don't need to be somebody that you're not. You don't need to be the leader that was there before. Figure out how you and your strengths and your personality can do that job to the best of your ability. Find support. This goes back to sort of the mentor comment, but it also peers and friends who can be around. Right, when you get a leadership opportunity, you're not just going to succeed from day one, and you're not going to have all the answers, and you will want people around you that support you, that you can go to, you can ask questions, or you can vent to. I think that support is a really crucial part of this step as well. And if they're already leaders, then they can also coach and help mentor you through that process too, which I think is super helpful. All right, and the last, I just want to reiterate, you can do it. You may have ups and downs, you may have hurdles, you may have bad days. But again, it comes back to this motivation and desire to push through. And when you feel overwhelmed, the best thing I can tell you is to just try to sit back and figure out what's the next wisest step to take, and just focus one step at a time. Okay, I'm gonna look for comments again. I'll make another statement. If there's comments or questions, please put something in the comment section so we can spend some time talking about it. We're doing on time. All right, so the last topic inside that I really want to talk about during our time together is something I call the People First Leadership Framework. It's a simple sort of mental map or mindset that I use when I approach sort of how to be a leader. And so I want to spend some time going through that. It's simple. I think it's easy to understand. And so my hope is that it's something that you can think through as you become a leader or in the process of becoming a leader. And once you are a leader, to help you be a better leader. So it goes like this. First, people must be first. And that's the first step. And the goal of that step is to create commitment from your team members to you as their leader. And so it's this, it's a relational step that says, hey, I will work with you. I will work with you anywhere, right? Because I know that I can trust you. I know you have the best interest of me and my team. And so your goal with that step is to create commitment to you as a leader. The second step is mission and vision comes second. And this step is about creating engagement with your team members to the work. Okay, so you created the sort of up and down connection in the first step between the team member and you. And this is about creating an engagement level between your team member and the work that they're doing. And it's about giving the team member the bigger picture so that they can understand how their work applies to that and why their work is exciting. We'll talk a little bit more about that in a second. And then the third step is results happen third. And this is about delivering successful results and actually achieving success to then create pride in your team members because they are successful. And you can see a real difference with teams that are successful and winning and sort of the culture and the attitude versus a team that is not being successful and struggling. And I think it's pretty palpable to see the difference between those two teams. There's a pride in that winning team that is super important. So that's a big part of this process. We'll dive in a little bit to each of those three steps. All right, I'm not going to read through these, but I wanted to give some somewhat practical steps on how you show people that you are putting people first. I just want to remind you that actions speak louder than words. So it's one thing to say, hey, the people are important. Hey, you want to put them first, but you've got to actually show that. And a lot of these are pretty simple. number 13 is small things matter, and some of these are small things. But if you can do these things, your team members will say, hey, he's in it for us, he's in it for the team, and they will feel that sense of, okay, it's not just about the leader, it's about us. And so that creates that commitment to you as that leader. Again, you want that feeling to be like, hey, I would work with you wherever you go. If you move teams, I want to come with you, because there's this commitment level that allows you then to apply that to your work and have super amazing results. Okay, so the next step is mission and vision. So quick just definition of mission, or what it is. I say the mission is the why, and it is the why we're doing what we're doing. Or another way of saying it, it's the important purpose behind the work. And then vision is the where. It's the where are we going, and it's about the exciting future. And if you can take those two things, the important purpose and the exciting future, and you can, it is your responsibility to make sure your team members know it and understand how their work applies to it. You get this engagement level with their work that is a superpower. You don't have to be the leader who is telling people what to do, or telling people to work harder, or to telling people to work more. What happens is there's a sense of ownership that your team members have to the work, because they understand the bigger picture. That is way more powerful and way more effective than you doing it from your leadership position. So the third step is supposed to be results happen third, but I wanted to cover a few negative paths real quick. So why does that order matter, right? So it's very important that it goes step 1, 2, 3. What I've found in my experience working with and around leaders who focus first on results is that it ultimately leads to negative outcomes. Often failure, but there are times where people push through, get the results, and do achieve a success, but it's not sustainable. It ultimately leads to burnout and alienation. And some people are really good to their people. They do put their people first, and their team members have commitment to them. But if you don't have that second step of really explaining the bigger picture and the mission and the vision, what I have found is that the team members, they just do what's told to them rather than doing the smartest. And we used to play this game called Lemmings, you can see on the screen right now, when I was a kid. And they just do what they're told to do, which, maybe there's some value in that, but they don't think through what they're doing, and they don't make the best decisions. Things are short-term. There's short-term thinking instead of long-term thinking. And again, maybe you do the first 2 steps, but you don't deliver results. Well, that's not okay either, because that's failure. And bad things happen with failure, sustained failure, right? That's when people lose jobs and companies go bankrupt. And so we do need to win. It doesn't mean we're going to be successful all the time. So there will be failures along the way, but we want them to be small, and we want to learn from them. And so you've got to be able to lead your team. You do have to be able to lead your team successfully to the outcomes that are necessary. All right, so let's say you do those 3 steps. You get the successful results, and that leads to winning and pride. And again, a team that is winning has an aura about them that is extremely powerful. And if you do that in the order that people must be first, mission and vision come second, results happen third, it leads you to what I call this momentum bonus, which is this sustainable success. Because what happens is when you do it in that order and the team wins, it just funnels right back into the rest of those steps. People will be committed to you because you've led them to be winning. Right? Engagement to their work becomes stronger because they're excited about what they're doing and winning. And so it creates a super powerful momentum that really helps your team continue to win and have success going forward. Okay. I am almost done. I am happy to take comments or questions. I'm going to do a quick recap just to summarize, and then we'll wrap this up. Okay, again, don't let fear stop you. If you have this idea that you want to try being a leader, or you could be a leader, don't let those fears that we talked about or other fears get in the way. If you believe in yourself, you can do it. Leadership is important and awesome and worth trying. And motivation is the first requirement that is necessary to make this transition. We talked about how to transition from developer to team leader. Again, adopt a belief mindset and believe in yourself. Lead from where you are right now. Grow your leadership skills by continually learning. Be proactive and go find opportunities, volunteer, ask for opportunities. And then when you get the opportunity, lead well and lead in service of others and make it about the success of others in the team and not yourself. And we talked about the people first leadership framework. People must be first to create commitment. Mission and vision come second to create engagement, and the results happen third to create pride. So, I mean, at the end of the day, what I really want is that you would consider being a team leader and do what this guy says and just do it. All right, let's see. I have a quick question. How am I doing on time? Can I answer a question?
Yeah, I think we're good. Time-wise, I think we're pretty much wrapping up. Joe is knocking the door, but that was a great session for, a lot of good points there. May, did you learn something?
Yes, I learned a lot about leadership and about the importance of leadership in, I'm sorry, can you hear me?
Yep.
The importance of leadership in software development. I found it very inspiring, and I'm hoping that many audience members found it inspiring as well. Hopefully there are some new leaders in software development.
I hope so.
All right. Well, thank you so much, Drew, for being a part of our conference today and our community here at CSharpCorner. And now it is time to welcome our next guest, Joe Guadagno.
Thank you.
I feel like I need to do this. Thank you.
Namaste. That's better way than shaking hands these days.
Right.
Yeah, right? You get it from a distance. I was thinking about doing my whole talk like this to tell everyone to mask up, but might be a little muffled voice. I always find it funny whenever you play that video. I'm doing well. I find in myself, especially watching those pictures, that I talk with my hands. It's the Italian in me. I always communicate like this. If I move my hands really fast, that means you're probably in trouble.
And where are you joining us from today, Joe?
I am in lovely, warm Phoenix, Arizona, which is in the southwest portion of the United States. So a little bit further south from where some of your early morning keynote speakers were from.
Wonderful. Well, welcome. We're excited to have you.
Cool. I am happy to be here. Let me know if I need to mute. I don't know if it kind of picks up because I can hear you guys speaking, but I don't know if it comes back and forth over the mics.
No, you sound good.
Okay, good.
Your sound is good and you're good to go.
Yeah.
Ready whenever you are. My screen shared.
The floor is all yours.
I'm Joe Guadagno. We're going to kind of skip through some of this since we are running late. I want to be respectful of people's times. Here's my contact information if you want to reach out to me. Email, Twitter. I stream 3 times a week, usually Monday, Tuesday, and Thursday at usually around 9:30ish Eastern time. So feel free to catch me on there. Other stuff I do, not that important right now, but you're really here to find out what .NET 5 is. So if you were here earlier in the morning, you attended the keynote where Scott Hunter and others talked about some of the stuff with .NET 5. We're going to kind of cover some of that, but more so the history of it. So we're going to start off with where we were from a software development standpoint, how we transitioned into .NET Core. Then we're going to cover kind of where we are now in this weird hybrid world. and then where we're going in the future, and then kind of where we are or what .NET is now. And I put ish in parentheses, mostly because it's not fully released yet, and we still have about a month left. Should be feature complete, but you never know. So we're going to cover some of the highlights of the things that are in here. But before we cover the highlights, let's take a look at where we were. So we started off with .NET Framework back in January of 2002. It was a cold, windy day in Seattle, lots of rain, probably some snow when .NET 5 or .NET 1 first came out. We then moved in October 2005, almost 3 years later before first real major release of it. Then we had .NET 3 in 2006, .NET 3.5 in 2008, which was a pretty big deal. And then .NET 4 is came out in 2020 or 2010. And then we have the 4.5. Then right around August of 2013, actually might have been a little bit earlier, these two guys made the big screen. They were on TV ads all over the place, ads on the web. It was a big discussion or arguments around whether or not Windows was better or Mac was better. One guy played the Windows, one guy played the Mac, and it was pretty funny for a while. They actually made a resurfacing with the Microsoft Surface ads, no pun intended. But Microsoft started noticing that more and more people were not using Microsoft Windows and were using things like the Mac, iPhones, and Androids. So they were trying to come up with a way to get some of their developers to be able to work on all those systems. So in June of 2017, which slightly warmer day in 2016 in the Seattle area, Microsoft released this little guy and the .NET Framework. That's when we did our initial hello world to .NET Core. So .NET Core was Microsoft's really first attempt at being able to build an application that runs on both Windows, Mac OS, Linux operating systems. They wanted you to be able to write code and have it run anywhere. It was the first real set of Microsoft software that they introduced into the open source community. And they wanted to be building a more modern framework that was highly performant and consistent across multiple platforms. So in the transition and moving from .NET Framework to .NET Core, something needs to happen to kind of bridge that gap. So that's where the .NET Standard came in. Now, the formal definition of .NET Standard is it's a formal specification of .NET APIs that are intended to be available on all .NET implementations. What that really means is .NET Standard was really a set of APIs that would guarantee a minimum set of what's called the base class library. So if you did something like query files in a directory, you can guarantee that that's going to work in one or more platforms. And let's take a look at what that meant. So this is a table that kind of shows you what .NET Standard is and what frameworks it supported. So if you look at the very top row with the light blue or anything in the .NET Standard, you see we have version 1.0, 1.1, 1.2, 1.3, all the way to 2.1. And then going down the left side or right side, depending on how you're viewing your monitor, you have different framework versions. So .NET Core, .NET Framework, Mono, 3 flavors of Xamarin, Universal Windows, and Unity. So you knew if you wanted to hit across any one of a given framework. So let's say I wanted to hit these different products. I wanted to be able to build apps in Android 7.0, Xamarin, iOS 10.0, .NET Core 1 or .NET 6. I can use version 1.5 of standard. If I moved up to 1.6, I had that same support. It's when I move up to .NET Standard 2, I can do it. But as you can imagine, that got kind of confusing for people. It's like you had to go to a table, click on a link, see the list of APIs. Was your API included? No. What do I do? Left. So that led to a lot of different kind of ways to build software. So we take a look at it. Right now we have .NET Framework, we have .NET Standard, and .NET Core. Those are 3 different ways to build applications on the Microsoft platform. You have your quote-unquote legacy stuff, which is written in .NET Framework. You have .NET Standard that attempted to bridge the gap between them, and newer stuff on .NET Core. But what happens if I want to build a user interface on a iOS device or an Android device? Well, we have Xamarin for that. Xamarin allows you to write code in C# and compile it and push it to Android devices and iOS. If you didn't have Xamarin, there was an open source product called Mono, which worked with .NET Framework that tried to do a lot of what .NET Core did before .NET Core was a thing, to allow you to write code once in .NET Framework and be able to deploy it everywhere. Then you had companies like Facebook that released something like React Native, that you can use JavaScript and you can write to a Windows device or an Android device or an iOS device using JavaScript. So great, I know one language. Then you had Ionic, which took it one step further and said, well, I can have you run on the web, I can have you run on iOS, I can have you run on Windows, I can have you run on Electron, that will allow you to install it anywhere using just JavaScript, and then behind the scenes, I'll magically convert it. So if you have a button on a form, whether it's running on a Windows desktop or an iOS desktop or an Android desktop, it looks native to that platform. Then you had Electron, which was created, which is essentially just a shell of application that kind of runs a JavaScript server behind the scenes. So you've probably actually used Electron a lot without even noticing it. Visual Studio Code, Microsoft, I wouldn't say newest product, but it's been out for over 2 years now, uses Electron behind the scenes, which is how you can run Visual Studio Code easily on a Mac or a Windows device. But wait, if you're trying to build for a game, you need to now know Unity too, because Unity uses C# to build games. So if we look here, there's like 9 different ways to build applications across platform. And that's a lot when you're thinking about it. I don't know about you, I consider myself a pretty decent developer, but having to know 9 tools or 9 different languages and be an expert in them is pretty hard. If you think about it, we have a lot of things that we want to develop on. We're looking for desktop, looking for web, looking for cloud, mobile, gaming, IoT, AI, all these things that require or that grab our attention. You know, we look at line of business apps or probably want to run desktop, web, maybe even the cloud, mobile devices. Oh man, I think my landscapers just showed up. It's going to get quite loud. Microsoft's trying to solve that problem with one way. They want you to have one platform to be able to write code for all these different environments. And that one platform is .NET, the platform for building anything. And as like I said, if you saw the early keynote, this slide was taken from that. I borrowed it from Scott Hunter. Hopefully he doesn't mind. So what does that mean for .NET Framework? Is .NET Framework dead? I don't want to bring up the old memories for some of us that have been doing coding for a while. We had the whole Silverlight. Is Silverlight dead? Microsoft started working on it. So in the cases of .NET Framework, yes, it's kind of dead. But at the same time, no, it's not really dead. And the reason why it's not really dead, even though it is dead, is probably because it's October and Halloween, and we get zombies and everything this time of year. For those in the US, we'll probably get the reference. But .NET applications are built, or more so the .NET framework is shipped with the within Windows. So your apps are basically safe in quote unquote forever, because as long as Windows is shipping, the .NET framework will support. However, that means there's not going to be any new APIs for it. There'll be security fixes and patches for your applications, but no new net features. Things come out like gRPC or YARP or the next latest and greatest thing that we need to worry about. That's not going to come out with .NET Framework anymore. So your legacy apps are still there, but it's time to start looking to migrating them out. So what does that have to do with .NET Standard? What about it? Is it dead? Yeah, kind of, sort of. For the most part, it's dead, but not really dead. Again, it was meant as a bridge between .NET Framework and a lot of these ecosystems. The moving forward vision, which we'll see in .NET going forward, a lot of that will be taken within the .NET itself. So what does that mean about sharing code with .NET Standard? Like I mentioned before, if you have an existing app and you need to share it on platforms that are not native to Windows, like iOS, Android, that kind of stuff, you're going to probably want to look at using .NET Standard 2.0. And there's purposely no spaces in there because these are the file monikers in the sharing. If you want to work with other apps or .NET Core, you're going to use .NET Standard 2.1 to share between Mono, Xamarin, and .NET Core 3.x. However, or actually, before we go into that, if you want to read more about it, Emo, the project manager, created a really great blog post about it, which you can see the short reference on the bottom of this page, where you can read a lot more about this. But going forward, the recommendation is you start using .NET 5 for any net new applications you're building, any net new libraries, portable class libraries you're building to get your biggest reach across. So let's talk about the vision of .NET. This will be a quick summary of what was probably talked about already today, but a good refresher to kind of reinforce the idea. So a single SDK, if you remember the vision I put together with, we're building for desktop, building for the cloud, building for IoT devices. We want a single SDK. We shouldn't have to learn 9 different things depending on where we're deploying at. So that's where we're getting with the single SDK. Cross-platform native user interface. So things like Ionic and React Native do that to some extent, where they'll do magic behind the scenes and convert that, but they have a limited reach as to what they can do. So it might have been talked about today, Project Maui. If not, it'll be talked about tomorrow. Project Maui is Microsoft's new user interface platform that's meant to be able to replace Xamarin Forms, WPF, good old classic WinForms, and ways of building out a UI. So you build it out once and it goes everywhere. Same thing, wanting to be the right tool to be able to build cross-platform web UIs that work on Windows and IIS, work on Kestrel Engine, work on Linux, the boxes, work anywhere. You also want it to be able to be cloud native, so I can work and run on Azure, I can work and run on AWS. And as an engineer, when you're building code, you don't have to know that. It's just all inside of the libraries. And as you've probably seen, I know Scott Hunter mentioned it earlier, speed and size is super important. They've been doing benchmarks since the beginning of .NET Core, and they continue to make things faster. Another thing, which is one of my favorites, is the instrumental improvements or instrumentation improvements. How many times have you worked on an application that you pushed into production, and then you got your next assignment, you started working on something, and then, hey, there's a bug in this app. So great, I haven't looked at this code base in 6 months. How do I go figure out what's happening? So they're trying to build a lot of that natively into your environment so you don't have to worry about that. So if you're like me, you're probably all excited and ready for this to come. What's the schedule look like for this? You're probably asking. Well, good thing I'm here, because I'm going to show you what the schedule is. You can find out more about it, that little link below. So take a look back at .NET Core 3.1. It was released in December 2019, and it's long-term support. Those of you who don't know what long-term support is, that is how long Microsoft is going to support this product. Their standard is 2 years since the last major release, or 1 year past the last major, 1 year past the last major release, or 2 years from when this was released, whichever is greater. So if you look, .NET 5, as it was mentioned, is going to be released at the .NET conference in a little bit over 3 weeks away on November 20th. .NET 6 is coming out in 2021, which is a long-term support release. And then November of 2022, we have it, and then November 2023. So what you see in the schedule is they've committed to one release every year, one major release. There's not going to be a lot of dot releases anymore because they're just going to continually churn out code. One of the things you're probably wondering is, why is there a difference between .NET Core 3.1, my first little bullet point here, versus .NET 5.0? Did you make a mistake and not type? Purposely remove the word .NET Core because Microsoft is removing the word core from there. They just want .NET to be the name you know, the name you trust. Not .NET Core, not .NET Standard, not .NET Framework. There's a lot of .NET things. So they're trying to kind of consolidate their branding together. Probably wondering why they skipped over 4 too. 4 was skipped because if you start referring to .NET 4, some people might think you're talking about framework. Some people might think you're talking about core. So they made the decision to just skip over 4 and go to 5 and say 5 and forward is just .NET. So what is really .NET 5, the whole purpose of this talk? .NET 5 is the start of the overall unification. So bringing all these platforms and frameworks together so that you have that one tool to make your code. So being able to get to this happy state of being able to write once and run potentially everywhere. So a little bit of how we're going to do that, or how they're going to do that. Here's a little table of different versions of .NET. So .NET 5 is going to be released with Windows support and some iOS and Android support. Then .NET 6 and 7 are going to have full Android, iOS support, and any other major platforms. It could be Linux in there. Maybe iOS doesn't become a thing anymore and that goes away, or Android goes away and now becomes, Windows based, whatever. This is how they're going to go forward. So they're going to introduce packages or target frameworks that you can add to your app and say, I want this to run on Android. So it will do all the translations for you. So what are we starting with? Good question. There's lots of great things that are coming in .NET 5. I'm going to kind of cover some of the key highlights that I think are important to know. And I'll probably get through these a lot quicker since we are close to running out of time for the event, and I would like to be respectful of people's times. So the first thing you've probably seen or might have heard of is .NET Records. When I first started reading this, I'm like, what's records? I don't want another darn data type that I have to remember, commit to memory, and then going to have the whole debate as to whether or not I want to use this or not, or should I use a class? I don't want to go back to the trauma of when the var variable or var keyword was introduced, and I was like, I have to have all my strings noted and ints noted. I don't want to use the var keyword. Now I can't live without the var keyword. In this particular case, records are, as the definition says, a reference type. They're essentially like a class, but a class that has extra stuff to it. They're meant to mostly have a fixed duration and only really have to do with data, which is why they're records. They don't have a lot of other helper methods, or sorry, they don't have a lot of other methods like get first name or save or things like that. These are ways to transmit data back and forth. And they have a lot of helper methods built into, so things like equality are built into it. Shortcuts for allowing you to create it faster and inherit. So we'll see some of that in the upcoming slides. And don't worry, I'm not going to rush. I'm going to still make sure the content's there, but I want to try to get it a little bit quicker if possible. So let's take a look at one of the samples for a record. So here we have a public record, which, by the way, if you're looking at .NET 5 documentation, some of the documentation in earlier releases had record as data. So you might see public data in this particular example, person. That was before they really finalized on the name record. So you might see some earlier blog posts with the word data in there, just as an FYI. Here you'll notice we have a kind of a weird syntax. So lines 1 through 5 are typical what we'd see in a normal class, so to speak. But line 6 is a weird looking constructor that has a weird lambda syntax to it. This pretty much says that I want a constructor for the person that's going to have a string first name and last name to it. And then that string and last name, which is highlighted here, is going to set the first name and last name property using the parameters first and last name. So whatever is passed in here as first name is going to go here as the first name. We'll be a little bit clearer in the next slide or two. Then you have teacher. So here it supports inheritance. Now I have a teacher class or a teacher record that adds an additional method called subject. And the same constructor, like in class inheritance, that you would imagine, instead of us doing the base here, we're putting it as part of the constructor here and saying, I want you to do the same thing. So it's going to take the first name and last name and use the parent records constructor for it, and then pass in or set the subject property based on the passed in sub parameter. Records are also sealable, which when I said that during my dry runs, I was like, oh, that's pretty funny. For those in the US know that if you have records in your when you're under 18 years of age, they can be sealed, meaning that you've had some kind of criminal offense and stuff. I'm like, oh, I'm glad I don't have any sealed records, because that would actually be pretty funny here. So same syntax here, just the word seal, which means I can't inherit from it or anything else. But what does this really buy outside of a shorter syntax? Some of these helper methods. So here is a quick helper method. Now, this all executes on the previous code that I had, which was the person and teacher on the previous two slides. So this slide and this slide. Here I'm able to compare. I didn't write any extra code. The person equals to the teacher. The difference with this one is it's comparing the individual items. So here it's comparing the first name and last name properties, and for line 2, the teacher, the subject property. In this particular case, it's going to say that they're not equal because the person object that's defined on slide 1 does not have a subject property, so they're not going to be equal. But if I created 2 persons here, like person line 1 saying Joe Guadagno, and then person on line 2 saying Mahesh Chen, that would they would say that they're not equal. But if I hit person equals new person Joe Guadagno, copy and pasted line 2, create another person Joe Guadagno, it would signify that they are equal. So that's kind of cool. I don't have to do a lot of cruff. And that's one of the things you'll see with .NET 5 is that they're reducing the need to write a lot of stuff. The compiler is getting smarter, as you'll see in this next coming example. Another way of writing positional records, or another way of writing records, is in what they call this positional record format. So now I just took the last 3 of the last 4 slides and consolidated them into 10 lines. Ideally, it could be 3 lines or 4 lines. It just depends on your formatting. But here on line 2, if you look at remember the previous person class, I had public getters and setters for it. Well, now they'll generate that for you based on the name here. So if we look at the very end of line 2, right here, you see I have the semicolon as opposed to the open and closed curly braces. So the compiler is going to say, you don't have any body to this record, so I am going to create the first name and last name for you. So I'm going to have properties that are available to you that are uppercase first, or uppercase F in first and uppercase N in name. Same thing with last name. The same thing holds true for subject and teacher. So now if you look at this code versus, let's say, this person or this, it's a lot less code. You don't have to do a lot of that plumbing or cruff, as some people call it, in order to get what you want. This to me is a lot clearer and more concise. That being said, there's another great feature coming in called the init-only setters. The init-only setters give you a really clear syntax for when it comes to initializing members. How many times have you created a class that had a property that you only want to set once and never set after that? So think of like IDs from a database. You only want whatever your ORM or database provider is to set that ID, but you don't want the code to change that. So a lot of times you have to go and create a public getter and setter, and then in the getter, you just return the value. In the setter, you look to see if the value was previously null. If it was previously null, allow it to be set. If the value was already set, you got to throw an exception. That becomes a pain. So there is this new init keyword as shown on line 3 here with our date of birth. I want to be able to provide people with the get date of birth. So I'm going to give them a get method, but I only want them to set it when they're setting the value initially, meaning they're setting it through the constructor. And this is a struct for just no reason. It could be a class or a record. I just chose struct in this example. So if you look at it, and here lines 1 through 5, I am outlining or creating an instance of a person. First name Joe, last name Guadagno, date of birth May 1st, 2020. And then in line 7, I realized, Joe, even though we're still in 2020 and probably May to now, which is October, 6 months in Corona years is like 15, 20 years old, you're still really not 5 years old. So I go and try to change it like I did here to 2020 or to 2000. Hint, I wasn't born in 2000, in case you can't tell by my glowing skin. But you'll get a compile error now that you did that because we initialize or we set this as an init only, meaning it's only able to be set in the constructor, which is a really cool feature. Another thing that you can do about it is here, you see I have it a lot shorter. I have a separate on lines 3 through 8, a way to go and check the value to ensure that you're only setting it in the constructor and making sure you're setting it. And I probably shouldn't say constructor. I should probably say an object initialization. Here I'm doing it in object initialization without the need of constructor. So I'm saying I want this property to be init only. So when I'm creating an instance of the variable, take the value. If the value is null, throw an argument null exception. So it's one less thing I have to do in my constructor, which makes this class a lot more testable and able to be injected a lot more easily without having a lot of stuff in the constructor. You want your constructors to be as small as possible. So in the spirit of keeping our code short, Microsoft is also introducing top-level statements. To me, this one kind of seemed relatively pointless, and I started playing around with it and realized there's actually some pretty good uses of it. So top-level statements are trying to get rid of the unnecessarily ceremony or cruft or extra stuff. So you think about it, you've been here for 5 or 6 hours, maybe 8, maybe 9 hours, or countless other presentations. You've all seen the mandatory hello world example. Looks something like this. This particular case, it's 12 lines. In theory, you can get this to probably 3 or 4 lines without indentation and stuff like that. Let's just go with 12 lines for now. You have the using statement on line 1, namespace on line 3, class declaration on line 5, the submain on line 7. All this is required because you need to build a console app. Why should I have to worry about that? Let the compiler figure out what needs to happen. I just want to demonstrate the console.writeLine functionality. So going forward in your .NET 5 projects, you can actually do that. Here's that same console app, but behind the scenes, the compiler writes out all that namespace stuff and consolidated that 12 lines now to 2. And in theory, you can actually really just do it in one. So now I can have a one-line console app that says system.console writeLine hello world, which is really cool in a couple of different scenarios. The first one that comes to mind is Azure Functions. Most of the times, if you're writing your Azure Functions or writing your code in a very object-oriented way, you have most of your business logic in a set of class libraries. So you can think of this just one-line statement saying execute that code for me. So that's really cool. One last feature I want to cover with the .NET Framework is another way to try to make things, or sorry, not .NET Framework, .NET. To try to make things more readable, there's been a lot of pattern matching enhancements. There's now you have the ability to match on type. So I can say, is this variable of type XYZ? Is this of type person, teacher, student, and do things based on that. There's now parenthesized parameters where you'll see where you can follow the math order of precedence to it. There's patterns to add or remove. There's negated patterns which say, is this not this? And then there's relational patterns, which we'll see in the next example. So here is an example taken from the .NET 5 blog post that says, this is an extension method to determine if a character is an actual letter. So here it says if C is, you see right here, greater than or equal to the lowercase a and less than or equal to lowercase z, or it's between uppercase A and uppercase E. For those of you who haven't been developing as long as I have, you notice the reason for this or in the middle is because there's actually characters in the ASCII code table between lowercase z and uppercase A. So you have to kind of do this translation. While this is readable, it's not as readable as it could be. So there's now the introduction of parentheses. So here, being the math person that I used to once be, I can see that now I want to execute this block of code first. So this is the first comparison. This is the second comparison, then third or fourth. So that's a lot easier to read. Next one is this, comparing a type with the not. So here it says, if person is not null. To me, this is awesome. How many times you type exclamation point equals? Now, when I'm thinking about that, without a C background or some, training in C#, that doesn't make sense to me. If I'm looking at this code, or if I'm a new person, how am I going to know what that means? This is a lot clearer to say what it's doing. It's saying if this person is not null, which to me, this is my favorite feature of .NET coming up. So here's a brief overview of what we covered. from a C# 9 standpoint. There's some more stuff coming out that we're going to cover in the next slide. If you want more, go to jjg.me/C# 9 to see the very extensive list of features that have been added to version 9 of C#. Next thing up we're going to talk about is cloud native. So the first thing which Scott Hunter shared in his demo is a lot of the open API, REST API friendly things. So you build a web API app. Now within .NET, you have the ability to generate clients. I mean, there's tools right now that you can do that. If you go to Open API tools on GitHub, there's a whole collection of generators. You pointed at a Swagger doc or an NSWAG, essentially anything with the Open API source, Open API specification, and it can generate a Java client for you, a .NET client, a Haskell, you name it, it can generate it. Let's see. Next up is gRPC, which stands for, the G is silent, but not really silent. It's Google that created a remote procedure call. This is a way to build high performance calls on a server using HTTP tools saying, I want you to go do this. It has a better way of transferring data back and forth on the wire, kind of like old TCP IP sockets, but with a lot less noise and wrappers around it. There's been improvements in the Linux side of building things. So if you're using WSL or Windows subsystem for Linux to build and deploy apps on the Linux platform using your Windows desktop, there's been some deployments for there, or some improvements in there. And then again, more of the focus on smaller single file apps. Then there's YARP, which is a reverse proxy that Microsoft built because they noticed they had a lot of internal uses for it. A lot of companies or a lot of internal teams were building their own. So they decided we might as well just build one for the whole company to use. And then while we're at it, let's make it available for anyone else. And then Project Tye, which I think Scott Hunter mentioned a little bit, but a quick overview of Project Tye. This allows you to, it's a tool to allow developers to build apps, microservices apps a lot faster. So let's think about it this. You're a new engineer starting at the team. You're working on this web API application. It has a web UI to it, API backend. That API backend uses SQL Server as well as a Redis cache for it. So I need to install 4 different projects on my machine. I need to install a SQL Server support. I need to install a Redis support. Then I need to figure out the configurations for all those. Project Tye makes it a lot easier for you to do that. You run Project Tye, you have your project be executed by Project Tye, and it will run those 4 different projects for you, including the SQL instance, knowing to bring on SQL in Docker, bringing on a Docker instance of Redis cache, and then getting all the APIs together so that your app knows here's the location for SQL Server, so it does some of the service discovery. Here's the location for Redis, so I don't have to distribute the connection strings with my application, which is also good for security because it helps to prevent you from checking in those credentials in security. So I don't know about you, but if you're excited about it, Project Tye is going to be pretty cool coming up. If you're excited about what .NET 5 has to offer for you so far and you want more, besides tomorrow, we have a full day of more .NET stuff. There is the .NET Conf, which is coming up on November 10th through 12th. Go to .NETconf.net to register. We're going to hear more talks from the community and more talks from Microsoft. Make sure you tune in tomorrow for any more content. That being said, I am done and ready for questions. You probably don't have any questions because I did such an awesome job talking about that no one's going to have anything. Either that or sick of conferences for 9 hours. That's enough for me.
Definitely not questions, but there were some great comments. I think people were watching and learning.
Oh, I hope that people are learning.
Definitely learning, and I learned a lot. This is definitely very exciting time coming with .NET 5.
I learned a lot as well.
I know. I heard that by next time we do this event, you're going to be coding with the rest of us, or you're going to be doing it.
I'm basically a developer now.
Yeah, it's pretty easy watching all these things, all these talks going.
So Joe May is our newest member to the team, so you'll be seeing her a lot more.
I look forward to it.
Yeah, and think looks like after today's work, she can take over these hosting conferences.
Yeah, look forward to it.
Yeah. Joe is a good friend. He's been part of CSharpCorner for several years. We do conference in India and other places. He's part of those. So just to anybody who's watching it,
thanks,
I know
David.
It's been definitely a long day. So hopefully all of you guys learned something. And David is there. What's going on, David? We'll see you tomorrow. So we have another big day tomorrow for a lot of .NET learning, and there's going to be a lot of new stuff there. Again, from 10 a.m. Eastern to same 3:30, 4 p.m. So any guys you're watching, please come back tomorrow. Any questions, comments? Joe, you wanna do something closing in the end?
Everything he just said, wait, that way. He just said.
Yeah, what he said.
Yes, tune in tomorrow. There's a lot of great content tomorrow with everything that's there. And rumor has it there may be a prize or two if you show up.
Yes.
If not, it sounds like I need to ship something anyway.
Yes, I think
put you on the spot.
We need to ship a lot of stuff from here. My room needs to get empty.
Cool. Well, again, thanks for having me. I look forward to the next one.
This time, Joe.
Nice.
May anything you want to say in the end?
Just thank you to Joe and all of the other speakers today. I learned a lot, like I said, and I look forward to coming back tomorrow, learning even more.
All right, guys. I know a lot of you guys stuck around for a while. I know we ran out 20 minutes late, but hey, it's all learning, and I didn't want to cut off any speaker while they're trying to finish their job. So tomorrow, again, there's great stuff. Check out the day 2 of our agenda there, and bring your questions, any kind of questions, right? The speakers love when you ask them questions. That means you're paying attention. It's like teachers, right? If you don't ask questions like, are you really sleeping? Are you really listening? And tomorrow,
like my mother, you say there's no such thing as a dumb question, only the unasked question. So ask away.
Right.
Yep. And we will announce some giveaways and prizes tomorrow. We have some cool stuff coming from CSharpCorner, and I heard a rumor that there's a new hat, which I wanted.
Ooh, very exciting.
So, all right, guys. Thank you all for and everybody, guys, behind the scene. Thank you so much, because it's not just what you see here. There's a Simon. He's working behind the scene continuously. There's a social media and marketing team. They're working since nonstop. And we had another conference going on side by side too on AI. We are supporting another conference. So these guys been working a lot. Thank you all. So I will see you guys tomorrow. Stay safe.
Bye, y'all.
Thank you.
All right. Have a good night.